Yes. Okay, so we are live now, so we can start the session. So I will quickly go through the concepts of week 1, 2, and 3 if time allows, and then we will see the some questions which already we have asked in one of the previous quizzes. Okay, so that you guys can get an idea how to deal with those kind of questions. I mean, if you are getting any problem, then how to deal with those problems. Okay, so I'll share my screen and then we will move on. So basically, week 1 and 2, week 1 is quite basic actually, but anyway, we will try to discuss all those concepts which has been covered in week 1, 2, and if time allows, we will go through the week 2, week 3 also. Okay. Okay. All right. So great. So let me share my screen. Can you see my screen?
Yes, sir.
Okay, all right, great. So let's start from week 1. Okay. So first of all, I will start with very basic thing. Can you tell me what do you mean by machine learning? Anyone? Any one of you?
Hello.
Hello. Yeah.
Sir, I'm really sorry, sir. I'm really sorry. Actually, I have registered for the Python data structures and algorithms,
Okay.
and I'm getting this link for the machine learning fundamentals, sir. I'm really sorry, sir.
Link for what? Discourse.
Yes, I got this link for machine learning fundamentals.
Hmm.
However, I should get the link for the Python using, data structures and algorithm using Python, sir.
Okay. So just write an email to support team. They will take care of that. Okay.
Okay, okay, sir. Thank you
Yeah.
so much, sir.
Okay. Yeah. Okay. So what is the machine learning? So basically, machine learning is if you see, is the study of computer algorithms, right? Yes or no? If I will talk. So this is ML is the basically machine learning is the a study of the computer algorithms, so that which improve basically automatically through experience and the use of data. Would you agree with me? That improve automatically automatically through experience and you and the use of the data. Yes or no? So this is just one of general intro about machine learning and the use of the data. So this is just a general definition about, you can say, one of the definition of machine learning. So after this, can you tell me what are the applications of machine learning?
Sir, it can understand unknown patterns.
Any okay, unknown pattern.
Spam emails.
Correct. Basically, can I say I can say predicting whether you know predicting whether an email is spam or not. Another application you can think of, like I can say forecasting companies revenue for the upcoming year. Yes or no?
It's weather forecasting also.
Weather forecasting also, yeah, that is one of the also ML example. So let's say weather forecasting, or I can say forecasting the company's revenue.
Face detection.
Yeah,
Yeah,
face
face
detection.
detection. for the upcoming year. And then also I can say recommending a product that a client may be interested in based on past experience. Yes or no? So I can say recommending a product that a client may be interested in
Movie recommendations.
movie recommendation also. Okay, so like yeah, movie recommendation. So you can see for the lots of recommendation on YouTube or OTT platforms, right? So those are the applications of machine learning. So these are just some examples of ML. So if we will move on the next thing, so basically what is the if I will say what is the ML models? Okay, so what is the ML models?
Hello.
Anyone, if you want to say?
Mathematical representation of data.
Presentation of
regression, classification,
Yeah, those are the methods. So I'm asking, okay, what model does actually?
probabilistic,
supervised and unsupervised.
Mathematical representation of data.
Okay, correct. So if I will talk about a machine learning model, so I can simply say a machine learning model. Okay, so I will write those things. So a machine. First of all, are you able to understand whatever the things I'm writing? Is it okay, or should I?
Predict the things with minimum loss.
Yeah, so basically I can say it's a program basically that can find patterns or make decisions from a previously you can say uh, unseen data set. Yes or no? So first of all, okay. So what are the two types of model we have discussed in week 1?
Regression model
Sir,
and
can I get these notes?
Yeah, notes will share once the session will end. Okay, so this just so two main top types of models are, first one is predictive models, and second one is anyone?
probabilistic models.
Probabilistic models.
model.
Okay. So predictive models and probabilistic model. So within let's try to understand in predictive models. So what are the models? Okay, so what do you mean by predictive models?
Let's try to estimate a value.
Basically we are predicting something, right, by using the model. Okay, so the two main things we have discussed in within the predictive models. So first one is called regression model. Okay, so what this regression model does, any example, anyone can you think of?
Predicting the house prices.
Okay, very good.
Predicting something based on something.
Okay, yeah, that is the general thing. Yeah, so
Like we
Sir,
are
usually enable
calculating the
surfacing.
house price, distance.
Correct. So also can I say, yeah, the similar example, can I predicting the price of land based on its area and distance from the market? Would you agree with me?
Yes.
It
Yes, sir.
basically finds the correlation between multiple variables.
uh, Based on its area and distance from the market. So these are the features I can take under consideration. What else? What can you tell me any other example?
Predicting stock prices based on the previous data.
Okay. And the second thing I can take predicting the amount of rainfall, in let's say 2022 based on some,
So
precipitation.
can I say this like we are inferring?
No, not kind of inferring. So inferring you can say it later, but suppose you are predicting something. So you have one output, let's say variable y, and other than that you have some input features. So let's say you are predicting the house price. Okay, so y will be price of the house, and what will be the other independent features? Let's say area of the house and number of bedrooms in house. Okay, and what else, distance from the metro or something like that, or distance from the, let's say, hospital and market. Okay, so those, based on those features, you are going to predict the price of the house. So predicting the price of, so price of the house is the one of the dependent variable, you can say. Okay, so what is the next will come under the class, predictive models? So one of the regression models,
Classification.
correct, classification. So don't worry, we will do the some questions and examples related to these problems. So I'm just quickly trying to cover these concepts. So classification model, within classification model, so what is the example? If someone is saying you have one classification model, what example can you tell anybody?
Classifies between dogs and cats, or
Correct,
apples
very
or
good. So basically
oranges.
you are taking,
Email is a spam or not?
yeah, that example, whether predicting whether an email is spam or not. And what else?
Sir, whether tomorrow there will be possibility of rain or not.
Very good, yeah. Rain or not. So whenever there is some classification, another I can take whether, predicting whether the patient is having, let's say any particular disease. So let's say patient is having cancer or not, something like that, right? So are you getting idea about these kind of
Sir,
models?
sir,
Yes.
in classification model, there are only two options or more than two options can be
More than
happen.
two options can be there. So for to understand the classification model, we have started with the two classes. Okay, two groups. So there can be more than two groups. Suppose you are giving the data of apple, orange, and banana, or something like that, right? So that
Okay.
can classify in three groups also. So what else? What do you do in probabilistic model? Anybody? What we are doing in probabilistic model?
We are assigning probabilities
Predict.
goes to the
Okay,
Predicting the
correct.
percentage of rain tomorrow or today.
Okay.
We are defining what comes next on the basis of like the previous data, but every possible outcome has a probability. Like this
Okay.
percentage of this can come, this percentage of this can come.
Yeah. Basically, I'm interested to what we are doing. Basically, we are evaluating how likely an event or, let's say, event or configuration is. Yes or no? So basically, probabilistic models are used for evaluating how likely an event or configuration is. Okay. So these are just general rough idea about basically different kind of models. Okay, one thing I would like to clarify. So are you able to read it out, or should I write a bit slow?
No, sir, it's fine.
It's fine, right? Okay.
It's better than mine, sir.
Okay. Thanks. Okay, so what is the learning algorithm? So let's try to understand. Okay, so don't worry about if you are getting confusion at any point. Just you can ask doubt and we will quickly. So what is the learning algorithm? So what is the key thing in learning algorithm we are doing? So basically we will be having data and data to models. Yes or no? So for example, so the price one, okay, so let's say price is equal to, let's say some A times area plus, let's say B times number of rooms and plus C times, let's say distance to metro. Okay, so okay, if I will ask what are the parameters here, then what will be your answers?
Area,
Row and
area,
distance.
rooms, and distance to metro.
Okay, can you come again?
Area,
Area, okay.
Room and
distance from
distance.
metro and rooms.
We can even add a interior, maybe interior
No,
color.
no. So A are the parameters actually. So what basically algorithm do? Algorithm use the data to get the best parameters. Okay. So basically, what is the role of algorithm? So algorithm use the data, to get the best parameters. So how will you find the best parameters? What do you mean by best parameters?
Which fit the data well, like the price should
Suitable
be
for
equal to the price
suitable.
should match to the labels multiplied by the parameters.
So the loss is minimum.
Loss is minimum, right? So the algorithm use the, so I mean we have to find the best parameter. So best parameter means loss is the minimum. So okay, loss is the minimum basically means so so there will be lots of values for A, B and C. Okay, so it will try to find these, so those values of A parameters A, B and C for, I mean, by using which we can say, okay, so for this model loss is minimum. So what is the loss? I will clarify in a minute. So to understand this, so actually there are two kind of important things in machine learning. So that's called supervised learning and unsupervised learning. So what do I mean by supervised learning? How will you differentiate in supervised?
Level data is given.
Okay, supervised learning is the labeled data and unsupervised learning is the unlabeled data.
Yes.
Okay, so see, this regression is the uh, regression comes under the supervised learning. Okay, so okay, what do you mean by labeled data? Means there will be output given to you. Yes, are you getting my point? Okay, so for example, what I'm trying to say, so what will be given to you? So you will be given to you, so let's say I'm writing just usual notation x1, okay, comma y1. So this x1 stands for, there are this is the vectors, right? This the one column vector, and y1. So this is output based on this, and then x2 comma y2 and so on, let's say xn comma yn. So suppose this is given to us. Okay, so what is the goal in supervised learning, I mean in regression? So we have to find a model, okay, model f, and such that, so this f of xi, okay, this will be approximately equal to yi. Yes or no?
Yes.
Yes, sir.
Right? And what is the role of algorithm here? So this algorithm outputs a model, okay, f such that, okay, can you tell me the dimension rd2? Okay, tell me the output r, right?
R, yes, sir.
Okay, very good. So first of all, if I will ask how to evaluate this model, I mean, how will you evaluate? How will you evaluate this model? Suppose algorithm outputs a model, how will you evaluate the model? Basically,
Fitting
you are
in the
going to
graph.
calculate, you are going to calculate the loss, right? Average loss basically.
Yes, sir. Yes,
So it's a 1 upon n, summation of I is equal to 1 to n, okay,
I minus fxi
f of xi minus
y
yi
Whole square.
Whole square, right? So, and in case of linear regression, actually, so what is the f of x? I mean, our model is, if I would like to write in general, so it is, yeah. Anyone? Can you tell me?
Mx plus b.
Yeah, mx plus. Basically,
X plus
see,
b.
we are
It's a
talking in terms
line.
of vector. So I will say it's w1 x1 plus w2 x2 plus so on. Let's say w and xn plus b.
W transpose X.
Yeah,
W x
if
plus b.
if you will write in terms of vector notation, so I can say w transpose x plus
B.
b. Okay, or else I can say summation. Let's say j is equal to 1 to n wj xj plus b. Are you getting my point? Okay.
Yes.
So let's do. Okay, everyone is having pen and paper.
Yes, sir.
Okay, great.
Yes, sir.
So let's do one very simple example. Okay, so that let's see whether you are getting these things or not. So I'm giving you data. Okay, directly giving you data. So suppose x and y. So x is, let's say, 1, 3, 4, and 5, and suppose y is 2, 4, 3, 6. Suppose one model. I'm just giving you model. Okay, just I'm giving you model. Suppose model f of x is x square minus 2 divided by 5. So what you have to do, you have to just calculate the what is the loss. Okay, just tell me the loss. Okay, so you have to some 2 to 3 minutes. Tell me the loss.
Sir, 3.4.
Okay, I need to calculate it. I just gave some random data actually. But anyway, so we'll cross check. Don't worry.
Say the more.
So I got one answer from one people, 3.4. What about others? So this is input, and this is output, and model f of x is given to you. How will you
Sir,
calculate?
3.4.
Okay, so I got 2 votes for 3.4. I will wait one more minute and then I will move on.
Okay.
So please, I will emphasize to you, please try it out, because you will get some sort of idea how to calculate these.
Yes, sir. I'm also getting 3.4.
3.4, okay, 3 votes.
Yes, sir. Me too.
Okay, great. Okay, let's cross check. So what is the f of x? So f of x is basically
X square minus 2 by 5.
Yeah, very good. So
first one, it will be minus 1 by 5.
minus 1 by 5. So minus 1 by 5 is minus 0.2.
Yes.
Right? And then 3 square is 9 minus 2, 7 by 5. That
7
is
by 5.
3 point, no, 7 by 5.
No.
1.4?
1.4.
1.4.
Okay. What is
That-
16 minus 2? 2.8.
That
Very
is
good.
14 by 5.
4.6.
4.6. Okay. So how will you calculate the loss here? So we have to calculate the average loss. So what is this? 1 upon n, summation I is equal to 1 to n. So if you see the formula, it's f of xi minus yi.
Y.
So we are basically, what is our goal? We have to find a model such that f of xi is approximately equal to yi, right? So that's why we are calculating the difference. It's the squared loss actually, okay? And we are taking average. So okay, so what we have to do? So what is the value of n here? It's a 4, correct? And what we have to do, f of xi minus yi. So we have to do minus 0.2 minus 2 whole square Yes or no?
Hmm.
And what is the next? 1.4 minus 4 whole square and 2.8 minus 3 whole square plus 4.6 minus 6 whole square. So if you will calculate it, so I am going with the majority, which is 3.4. Okay.
Sir,
So this
if
is
we keep it as fraction, like normal fraction, not decimal, then it will be easier in calculating, right?
yeah, it's that's the smart approach actually in the during
Hmm.
the exam.
Because everything is divided by 5 only, because it
Yeah,
is
that will
written
be
as
outside actually. If
yes,
you,
yes.
yeah, great. Yeah,
5
that's
square will be outside.
correct.
Sir, in some PYQs, I see like they are asking squared error. Like that refers to mean squared error, or
Yeah. This is the mean squared error. Right?
but in the question, if it is mentioned only squared error, what does that mean?
Yeah, you have to calculate this one, right? This is the squared
Okay.
error.
Like,
Okay.
should we divide by n even if it is squared error? They ask.
Which PYQ? Maybe.
Yes, sir. In the mock test, some square sum of square are asking.
Yeah,
So,
sum of
Okay.
squares refers to only that square part, right? Like not dividing.
No. So okay, maybe you are asking method of least sum of squares, right?
No. Here only, like they are said like to calculate the sum of squares in the loss only, like sum of square errors.
In the mock.
Like not divided by 4. That's
Yeah,
what we are
correct.
asking.
Not
mock
divided
question
by
is
4.
given. Mock question is given.
Mock, right? Let's see where it is. So what I would recommend you, just try on your own, and we will discuss where it is. Yeah, so here you can see it's clearly mentioned mean squared loss, correct?
Okay. If it is only squared error, squared,
One question I have seen, sir. I have seen.
Where it is? Okay, just try it out. We will discuss the mock, right? Or TH will discuss the mock. They will.
sure.
Okay, are you saying this squared sum
Sum
of
of square,
squared
yes.
residuals of?
Yes, sir. Yes, sir.
Actually, okay. I have a question related to this. I will discuss. Okay, don't worry. I have one question. I have kept one question related to this concept. Okay.
Okay.
So actually, from exam point of view, what formula should we use?
See, if it's it will be clearly mentioned whether you have to calculate mean squared loss or not. If something there is you have to fit a linear regression. Okay, for that I will tell you. I have one question. I have one question related to that. I will tell you how to approach those kind of questions. Okay. So I have collected some questions. We will discuss those questions. Okay.
So,
Don't worry.
what about the 0-1 loss? Like, is it related to this part?
0-1 loss. Yeah. So I will tell you. Don't worry.
Okay.
So okay, this is question related to this was one of the example related to regression. So what about what are the ways in classification? Okay, classification will come under supervised learning or unsupervised learning.
Supervised
Supervised.
learning.
Supervised learning.
Supervised learning, right? Why? Because it's a labeled data, right? So what do you mean by supervised learning? I mean, what is the role of supervised? I mean, what do if suppose you have to explain to someone in layman terms, so how will you explain the meaning of supervised?
Training the data, sir.
Can you
Training
tell me
the
very
data
briefly?
when we
Putting the
already
model
have an
to the
output.
data.
Actually get a continuous output in this.
Okay, continuous output is one of the example, but see, classification you won't get right continuous output.
Curve fitting type.
We are fitting the model to a
See,
data.
basically, you can say supervised learning. Something is happening. I mean, there is one supervisor.
The data is defined.
Yes, sir. Train the data.
Here we get if we give some input, we get output here.
Correct. So that is the labeled data. So if I will ask, okay, suppose I would like to mention meaning of the supervisor. So suppose okay, so I think in each school there is a small child. So teacher will teach them let's say addition of 2 3 5 plus 1 5 7, something like this, right? And some output is there.
Yes.
Yeah, right. Then some let's say addition of 3-digit number. Okay, just go with this. And what is the role? Okay, who is the supervisor here? Okay, first of all, so there will be some homework, right? But in homework, or let's say in exam, first of all, that child or that student will learn method how to do addition of 3-digit number, correct? But in exam, he or she will get unseen data, right? Unseen data means addition of 3-digit number, which is not in, let's say, he didn't, I mean, he practiced with some different number, and in exam he got something different number. Okay, so far so good. So there is one supervisor that's called which is teacher in this particular example. If you see, are you getting?
Yes, sir.
Yes.
Okay, so basically you can say, so if you go with the word, so there is one supervisor. So if in case of model, can you tell me who is the supervisor? I mean, what is the supervisor then?
Sir, output.
Output is the supervisor.
Supervisor is the learning algorithm.
The one who is teaching the.
Sorry?
Loss function.
So
Loss
data,
function.
sir, data.
Okay, just think of this. See, just think about this. So basically, what I can tell you. So see, first of all, whatever the output will be here, it will be a label, right? I can say this is the label.
Yes.
Okay.
Sir.
So basically, how addition works, he or she needs basically needs to have a, basically you can say, mental model of addition, right? For the for that particular students. So and what is the meaning of mental model of addition? So if we'll talk about here, so basically he or she needs to or else I can simply say the model learn a function. I mean ML basically, if I will talk in terms of ML, it learns a function from input basically. And what is the input? Basically, let's say with this example, so basically question to the output.
Yes.
Right? And what is the output? Output is answer. Answer for that question. Yes or no?
Yes, sir.
Okay. Yeah, this is just one of the simple example. But anyway, so let's try to understand the classification. So in classification, again, we will be having a labeled data, right? Some input, some x's and some y. So it will be x2, y2, and let's say suppose till xn, yn. Okay. So what is yes?
Sir, so what you are saying is, in supervised learning, for n number of inputs, there will be n number of outputs.
Yeah, so we will be having we will be giving the, I mean, we will be having the data and output along with the basically input and output. Okay, so here this is the input, this is the output, this is the input, and this is the output. So in supervised learning, the model it will give you algorithm based on this data itself. Okay, and it will predict something. So whether it's a classification or regression, that depends actually. So in classification, this is the input, and what is the output? So output, let's say we will be having two class. I can represent it as a +1 and -1. Okay. So what is the role of algorithm? So this algorithm outputs a model, basically model f. Okay. From where to where? From RD to
R.
R. Is it R?
+1 -1.
Correct, right? So this is just a classification, right? The output will be either +1 or either -1, right? Either, let's say I can make it as a spam or not spam. Okay. So what is the loss here? I mean, how will you evaluate this model?
Number of times the output the output from the model differs from the actual y value.
Basically, I can say fraction of misclassification.
Fraction of incorrect entries.
Yeah, or misclassification. Yeah, both is the correct. So I will use the indicator function. Okay, which is so how it works. So what you have to check whether f of xi, the model, is not equal to yi. Okay, and what is this f of x basically? So basically this is sine of, yeah, anyone? Some function. So let's say w transpose x plus b. Okay, so let's try to do one very simple example. It will be clear how to calculate the loss in case of classification. So suppose input x is given to us as a well, let's say 1 comma 0 and 2 comma 2 and then 3 comma 1 and 4 comma 5 and 5 comma 4 and let's say 6 comma 5. Okay, so for this suppose we have classified it as a plus 1 and plus 1, it's a minus 1 minus 1 minus 1. Suppose what is the model is given as f of x is sine of let's say x1 minus 3x2. Okay, so we have to calculate this. So what is the sine of x1 minus 3x2? So first of all, this 1 is x1 and 0 is the x2, right? Yes,
Yes.
or no? Yes. So what is the 1 minus 0? 1 minus 3 times 0 is 1. So sine of 1 is plus 1.
Plus 1.
And then 2 minus, this is minus 1?
Minus 1.
Right? 3 minus 3, this which is 0, which is again
Plus
1. And then tell me minus 1?
Minus 1.
Minus 1.
Minus 1?
Minus 1.
So what is the loss? We have to calculate the loss 1 upon n, summation I is equal to 1 to n, indicator of basically we have to count the number when f of xi is not equal to y. See, for this is equal
1
1
by
by 6.
This one.
yeah, for this one this is not equal to, right? Other than this, you can see this is equal, this is equal, this is equal. This is the basically incorrect one, correct? Basically what will be the answer? It will be 1 by
6.
Yeah, so 0.166. So this is the way you can calculate the loss in case of classification problem. Okay,
so
yeah, are you able to follow me? I mean, is this okay?
Yes, sir.
Okay.
so,
Yes.
so
Yeah.
small doubt
Yes, yeah, go ahead.
about the f of x. You said you have written it at the top of the table, but do we have to assume it khud se, or
No, it will be given to you. See, model will be given to you.
Okay, so only we have to check whether like loss and all, right?
Loss, yeah, loss point. Okay, so if you'd like, I have one question. I can solve it right now. This is the misclassification rate. So would you like to solve it right now, or first we will finish the week 1 concept and then we can come up with the question? What is it?
Finish the week 1 question.
Okay, great. Then let's finish. Then we will try to question. Okay, so that, after this, I would like to discuss the there is something called. Have you heard about this test data and then
Yes, sir.
validation data
Yes, sir.
and
Yes.
Training data.
basically before this training data and all. Okay, so what are these things? Anyone can explain to us?
So validation data is the data before all the filtration we do and
Okay.
data cleaning process, and training data is the after data where we select a particular data to train the model, and test data is on which we test the model, and then after that we check what is the losses and all.
Okay, if you would like to mention the basically percentage, then how will you explain? I mean, how much?
Sir,
you
is
take
it
for-
like जो validation
Sir,
data होता है
validation.
उसमें से
Validation is
थोड़ा clean किया जाता है to make the training data so that the data gets
Sir,
we can use the data, and the test data.
Suppose I have thousand rows with some features. How will you do?
800
700
rows will be given to training data.
Okay, basically let's say 80%. You can take 80 or 70.
70% given.
Okay, let's take 70. Fine. Okay,
Yes, sir.
70% to training data and
20%
for validation.
Test data.
15%.
let's say 15% validation, and then
15% for testing.
okay. So okay, this is okay. So if let's try to understand in terms of very layman term, what is this meaning of this training, validation, and test data actually. So suppose I'm interested. There is a student. Let's say we are interested to evaluate this. Let's say he or she is studying for a particular exam. Okay. Now, what is the role of training data? Okay. So how will you do? So basically, in training data, what happens? Okay. Suppose this is I would like to suppose this is training data stage. So what happens basically? So, okay, what will you do in training data, or he or she will do the training data? Basically, he or she, basically, I can say you read lots of, textbooks. Yes or no?
Yes, sir.
And
yes, sir.
solve practice questions.
Yes, sir.
Here
So,
it's
sir, we fit some data in fit some equation or like that curve like that in the data. Suppose we want to find a function, so we fit a line or a curve to that data like that.
Yeah, basically. So, okay, let's try to understand elemental, then we will go to technical. Basically, so, okay, so if you see, what do you mean by 70%? So 70% of this whole process, basically, you will read lots of textbook, or basically you will watch here, let's say in our degree, you will watch lectures, you will solve activity questions, you will do practice questions and all, right?
Notes also.
Yeah, take notes and all, right? And basically, what is the analogy in training data? Basically, you are learning the concepts, right?
Yes.
All right. Now, how will you validate yourself?
The mocks and graded
Very
assignment.
good. Correct. So basically, you take mock test, right? Or you are
Yes. Firstly, practice assignment, activity assignment, mock test, graded
see,
assignments.
this practice assignment and all can come under the training part. Okay. So basically, you see before exam. Suppose this Sunday is exam. You are solving your mock. Okay. So you are taking a mock test to see how well you are prepared. Yes or no? And based on this, you will change the things, right? You will change something. You will see, okay, this is the something I need to learn, and also basically what you are doing, you are finding your weak points and what are the area to improve. Okay, what is the test data?
So then final marks.
Final exam.
Basically, yeah. So you are appearing for the final exam. Okay. So which will prove that you have learned the things, right? Are you getting my point?
Yes, sir.
Yes,
okay.
sir.
So basically this is the part of training and testing, and basically, so see, in simple terms, if you see, so training data is something tells what we learn from, right? Let me use something different color. So what we learn from, basically. Okay, so if what is the purpose? To understand the pattern. Yes or no?
Yes.
And here in validation, basically what we practice on.
Yes.
Right?
Testing that this is yes, sir.
Like
Basically,
we
and
are
here,
testing.
yeah, and in analogy, I can say to improve the model.
Yes, sir.
Yes or no?
Yes, sir.
See, what you will do if you are giving a mock test, and based on that you are identifying, okay, this is my weak point and this is my strong point, and accordingly you are you have to improve or something like that. Yes or no?
This is like performance of the data, sir. Performance.
Yes, you can say. So, and here what we finally.
Yes, either future prediction. I think is this last one, na?
Yeah, this is some for two unseen data. Okay.
Yes, unseen data.
So here it will be to measure. I can say this will help you to measure the real performance. Okay.
Yes.
Okay. Is the rough idea clear about this training, testing, validation data? Yes. No? So this 15% you will use unseen data to test your model. Okay. Anyway, so
Hello.
Yes. Yeah. Go ahead.
So can you please explain the validation data again?
So validation is something, okay, let's try to understand with this example. This, you take a mock test. Okay, first of all, you are watching lectures, you are solving activity questions and practice questions, right? Basically you are learning, right? You are basically we are trying to understand the pattern. Okay, pattern means how to solve the questions and all. Okay, in validation you will see what are the things we need to improve within the model. I mean, basically something called hyper tuning, and also that will come later. That's deep things in machine learning model, in this machine learning board. But let's try to understand the rough idea here. So validation means you are trying to validate yourself. So basically you will give a mock test and just to check whether how well you are prepared for the exam. Okay, and then you will see, okay, this is the weak point and this is the area where you have to improve. So basically that, that I told you, right, the hyperparameter and all. Then the
Yes, sir.
finally comes under the test data. So you will test data is something you can understand like this, the final exam. Okay, you appear for the final exam. So in the final exam, so there will be different questions, right, with something unseen questions, and whatever the things you have learned, you have improved, that you have to apply for the during the final exam. Okay, yes, no?
Yes, sir.
Okay, all right, great. So next is unsupervised learning. Okay, so in unsupervised learning, okay, so okay, anyone, would you like to explain what is the unsupervised learning?
Unlabeled data.
Yeah, so we don't have labeled data, right? So in case of supervised learning, we had labeled data, right? We had input and we had labeled output for that. In case of unsupervised learning, we don't have unlabeled data. Sorry, we don't have labeled data. It's unlabeled data basically.
Yes.
So we will be giving the data itself, and we will the model will try to identify the basically pattern. Okay, so in unsupervised learning, something called dimensionality reduction and all. So okay, what is the role of dimensionality reduction? Means you are giving lots of data basically. Okay, suppose there is some 30 features. Okay, so and it's hard to visualize and work with that. So what you will do, let's say you reduce to 4 features. Okay, it will model will reduce to 4 features without losing much information. Okay, without losing much information. So one very simple example for this. So suppose you guys are in diploma level, right? So can you tell me what are the okay, how many subjects are there in diploma level?
12.
Okay, before that, in unsupervised learning, what it does, it understands the data. Okay, so the main thing is you have to give the data only. It's understanding the data. So understanding the data means it build models. Okay, basically that models compress, explain, and I can say group data.
Yes, grouping data is the
main thing. Okay, so for example, how many subjects are there in diploma level?
I think eight
12 or
16.
Let's say 10, right? I think
6 courses and
12 subjects,
projects.
12 subjects and 4 projects.
Okay, 12 subjects. Let's say you have 12 subjects. Okay, for example, the thing is, suppose I give you exam marks in this 12 subjects for each students. Okay, now it's hard to visualize these things.
Yes, sir.
So what I mean, suppose there is subject 1, subject 2, subject 3, and so on. Let's say subject 12.
Yes.
Okay, and there are I'm giving the marks for, or let's say grade for each student. We don't know how many. Let's say some 20,000 students, for example. So it's hard to visualize and try to. So it's basically time consuming or something like this. Yes or no?
Yes.
So what you will do in dimensionality reduction. So let's say I'm reducing these whole things in 2 components. Okay, so what will be, and without losing too much information. So okay, let's say I can, okay, Anyone of you can tell you what will be those two components?
Yes, sir. This may be programming and data science, two subjects we can bifurcate.
Correct. Basically, I can say I can reduce this 12 features. Let's say this 12 features to 2 features, and those 2 features I can say as a
One from data science and
data
one
science
from
and
programming.
programming. Now, if I would like to plot, then I can easily plot, right? Let's say data science and programming. Yes or no?
Yes, sir.
Yes.
Okay. So here, what happens? We have too many dimensions. Yes or no? Are you getting the idea behind this dimensionality reduction?
Yes, sir.
Okay.
Yes.
So one example is image compression. So image compression. So what happens if we reduce the dimension? Basically, so we are reducing the amount of data which needed to represent an image while keeping it visually meaning. So I mean, suppose you have 1000 cross 1000 pixel image. Okay, so there will be lots of numbers, right? What you will do? You will reduce the dimensionality. Okay, anyway, let's try to understand. Okay, rough idea is clear regarding this dimensionality reduction.
Yes, sir.
Yes.
Okay, all right, great. So let's try to understand with some notations. Okay, so in unsupervised learning, so something called dimensionality reduction. Okay, so basically in dimensionality reduction, what we are doing, we are basically, what is the key thing? Compression and simplification.
Yes, very good.
Now, okay, see, as we discussed, so in case of, I mean, opposite to supervised learning, here we don't have labeled data. Labeled data means we don't have output. In supervised learning, we had input and we had output. Then model learns the, I mean, it will give you algorithm, and then we have the model and all. We'll try to see which has the minimum loss and something like that. But in case of unsupervised learning, we have only data. Okay. So let's say x1, x2 till xn. Okay. Now here we have something called encoder function. Okay. So what is this encoder f does? So it's from rd to, let's say, rd prime. Okay. So what this encoder does? So here this d prime is less than d, because we are reducing the dimension. Okay. And what is the task of decoder?
Again,
RD dash to RD, and where again D dash is less than D, right? So basically, what is our goal? What is our goal?
Is to get the maximum maximum.
This is this is encoder, right?
Yes, sir.
Right. And then if we decode, if you apply basically g of f of xi, this should be approximately equal to xi or not?
Yes, sir. Yes, sir.
Right. I mean, we are trying to not lose too much information.
Yes, sir. Recover the maximum of the original data.
Right. Okay. How will you explain the loss? So average loss will be 1 upon n here, equal to, I mean, 1 upon n into summation of I is equal to 1 to n, norm of g of
f of xi,
xi, yeah, very good, minus xi. This is basically norm square. Okay. So this is the way you will calculate the things in case of dimensionality reduction. Okay. So let's try to do one simple example and then move ahead. So in case of dimensionality reduction,
Can you show the previous formula?
Yeah, this one.
Yes. The goal, the goal is g f x of 1. So
yeah,
we basically convert it to a separate xy, right?
No. What do you mean by converted to separate xy?
Like we take the original input, and then by dimensionality reduction we
reduce its dimension, and then later again we convert it into original dimension.
Okay.
Suppose this is input 1, -1 and 2, and let's say 0, 1 and 3. Okay, so suppose this is the input only, right? And what is the encoder function? So suppose this is f of x. Okay, so I'm giving you encoder function. So suppose f of x is x1 minus x2 plus 0.5 x3. Okay, and this decoder function, let's say g of u is nothing but let's change, it's 0.3 times of u, and let's say minus u and 2. Understood? Okay, can you use these things and tell me?
Sir, give me 2 minutes. Give us
Yeah,
2 minutes.
yeah, all right, yeah.
Sir, 5.148.
Okay, I don't know, I need to calculate it. So your answer is 5.148.
148.
Okay, let's wait for other. Okay, so others are trying, right? I'm waiting. If you are not trying, let me know. Okay, accordingly we will move ahead. So it would be great if you are doing right now, because then you will get some confidence. Okay, you are able to do the questions within 2 minutes or 3 minutes. Okay, that's something practice for you.
Sir, I was solving some PYQs, 1 or 2 I just solved. So both have 16, 15, 16 questions. This much will come only.
Yeah. So you will get that much questions. Okay. If questions are let's say more number of questions, then it won't be. It will not be too much lengthy. So basically, paper will be designed such that you should be able to do within given time limit. Okay, some questions will be very conceptual based. I mean, let's say something, you see the question and okay, with this is, you'll be able to do within a minute. Some conceptual questions will be there. Some numerical questions will be there also. But anyway, okay. So I will wait for 2 more minutes and then we'll move ahead. Okay, should I wait or should I move? Anybody?
सर सॉल्व कर रहे हैं वो बस थोड़ा सा बाकी
Okay, should I solve?
Yes, sir.
Okay, so this is encoder function. Okay, okay, so it will reduce the dimension. Okay, so you will get one. I mean, it's from R3 to R. Yes or no? You can say this is in R3, and f of x will give you in single. So okay, what is? Tell me what is the value now? Can you calculate? Someone can open the calculator and let me know. So -1.
Yes, sir. First one will be minus 2.5.
Minus 2.5, and then it will be minus 0.5.
Minus 0.5
Yes.
both. Next one also minus 0.5.
Okay.
Next one is
Then
3.
It's 3.
3.
Next one is 0.5.
0.5. Yeah, correct. Now you can see it. So here dimension has been reduced. Yes or no? Now what is the next task? It's g
Find
of,
the GU
of
U.
f of x, right?
Okay. Yes, yes.
So whatever the u is here, right? Whatever the you can say in within the bracket is there, we have to make it in now in the original version. So 0.3 times of u minus u and u. So what is the 0.3 times of basically minus 2.5?
Negative
Minus
0.75.
0.7
and
2.5
minus 2.5.
minus 2.5.
Very good. And then minus 0.15 and 0.5 minus 0.5, and then minus 0.15, 0.5
Same.
minus 0.5, and then 0.9
9.
minus 3 and 3, and then 0.15
0.15.
minus 0.5, 0. So this is g of f of x. What is the next task? We have to calculate this norm difference of g of f of xi minus xi, this norm square. So let's do this one. So basically what you have to do, I mean some people get confusion here. So what you have to do, so this is your xi, this is your g of f of xi, right? So what you have to do here, we have to subtract all the individual values and the norm square. So basically it will be minus 0.75 minus of 1 square. Are you getting my point?
Yes, sir.
So I will write minus 0.75 minus of, so this minus minus will become plus whole square plus, okay, this 2.5 minus of 1 whole square plus minus 2.5 plus 1 whole square. What is the value? Anyone can calculate and let me know.
Sir, 4.562.
Okay, let's take it 4.56. Okay.
Next one is 5.82.
Okay, so you got the idea, right? How to calculate this norm
Yes, sir.
square, right? Yeah. The next one is
5.0.
So here we use g of u.
Yeah, g of u. So g of u means whatever this in u is there, right? We have to make it 0.3 times of u minus u and u. So here what is the u you can consider? So this f of x you can treat as a u. Okay. So this f
Like
of x
a
is,
composite function, we are considering f of x and g of u.
so yeah, this is g of f of x. Yeah, basically. So the, first you applied f of x, then you are applying g of x. Okay.
G.
So here what it will be? It's a
1.82.
Okay. What is the next? Someone.
5.01.
Okay, 5.01, and what the next?
8.52.
8.52.
Okay, very good. So let's say if you see, so what is the basically loss? Loss is 1 upon n and summation of all these. So we have to do, so what is the loss? Loss is 1 upon 5 and summation of all these. So it will be
25.74.
5.82 plus 1.82 plus 5.01 plus 8.52. So basically this will be
5.74.
No, divide by 5, after divide by 5.
After divided 5.14, right?
1.4.
5.148.
Okay, so I'm going with this I didn't calculate, so you can cross check this value. Okay. Okay, so basically, okay, so what I trying to say, you got the idea, right? How to calculate the loss in case of dimensionality reduction? Yes or no?
Sir, actually, please explain the last column.
This one. So what
Yes,
we have to
how
do?
you
We have
put
to do,
on the
yeah,
values.
g of f of xi minus xi. So just try to understand. So in g of f of xi, how many values are inputs are there? 3, right?
3.
This is basically, and again there in within x, this is 3, right? How will you subtract this vector to this vector? It's element wise, right? And this is
Yes.
norm square, so we have to do the square and then we have to add. So it's a minus 0.75 first element,
Oh, okay,
minus of
okay.
minus 1.
I
Understood?
got it.
Yeah. So the next concept under unsupervised learning, which Prof has discussed, what is this? Sorry, not dimensionality, density estimation. Okay, what is the role of density estimation? Can you quickly, anyone? What we do in density estimation?
We create clusters of those. We calculate the probability.
Probability.
Okay.
To find
So basically,
the
density estimation, if you go with the word, go ahead. Yeah, sorry to interrupt. Yeah, go ahead, please.
Yeah, to find the region in which most of the data points lie.
Okay. Yeah, correct. Anybody else?
Where data points are most concentrated and where there are rare in a data set.
Okay. So basically, this density estimation is the process of estimating the probability distribution, right? If I will write, so I can write is this is the process of estimating the probability distribution of a random variable and based on observed data, right? And that's we should have the data first of all. So see, basically you see, if you have a data set, so you want to know how the data set how the data is distributed, yes or no? Basically and the density estimation tries to give you the answer of what question? Basically which values, someone told that's correct actually, which values are more likely, and basically what is the, I can say, shape of the underlying distribution. Okay. Okay, so can you tell me the any real life example where this density estimation is useful?
Figuring out what products are more likely to be sold.
Credit card, fraud credit.
Okay, can I say this fraud detection in banking?
Yes, sir. Yes, sir.
Right.
Transaction.
So how it will identify whether this basically, so basically what it will do, I mean what happens, so it will estimate the I will say the normal spending behavior of a customer. Right, behavior okay, and then what will be the next task? So what the transactions, okay, with the low estimated density.
Yes, sir.
Okay, so low estimated density means basically rare events. Okay, so that can be flagged as suspicious. Are you getting?
Yes.
Are you getting this things or not?
So what if the suspicious activities are a part of normal spending behavior as well?
So normal spending behavior, so basically see, suppose you are getting something curve or something like this, okay, there is some rare events, right, with the low density. So there might be some too much transaction, extreme transaction, something like that.
Very high value.
High things, yeah, basically it will detect the rare or unusual pattern. Okay, some outlier is there, then you can consider as a fraud something. Okay, and something, see, let's say traffic pattern analysis. Okay, so in traffic pattern analysis, what it will do, so it will count the cars passing let's say junction every hour, for example. And how this density estimation help you? So it will help you to visualize the peak traffic hours, right? Where is the peak, where is the low traffic or something like that. Are you getting my idea this about density estimation?
Yes, sir.
Okay. So, okay, so let's go to the question part, okay, because we have to discuss the things. So, what will be given the things? We have been given the data, okay, let's say x1, x2, so on, xn, okay, and what, okay, what is the next step? And what is this each exercise? Each exercise in will be in RD, and what we are going to do, we are going to do the probability mapping. Okay, so probability mapping, which is P from RD to, tell me, let's say R positive, right? And there is one condition, since this is probability, that sums to 1.
To 1.
Very good. Okay, what is the goal? As we saw, we had some goals. So this P of x, this P of x will be large if x is in my data and low otherwise.
Yes, sir.
Yeah. Okay, what is the loss? So loss is 1 upon n
Log of px, log
is equal to 1 to n minus log of p of xi. This is the way we are calculating the log in case of this density estimation. Okay, so I will give you again one simple example. Just calculate the loss and tell me. So suppose this is x and then 3 and 0.5 and then let's
Excuse
say
me, sir.
4.95. Okay, yes.
Sir, do we need to memorize
And
all these
suppose
formulas,
P of
or
yes, yes, all
useful information
loss functions, all loss things, yeah, should be in your mind. So this P of x is, suppose in this example I took very straightforward, is 1 by 5, 1 by 5 is 1 by 5. So you can see this, all the probabilities, if you sum, they sum up to 1, right? So how will you calculate the loss? Okay, so loss is minus log of P of xi, right? Can anyone, can you calculate minus log of P of xi? Okay, basically, can you calculate the loss? Basically, it will be 1 upon 5, sin is equal to 1 to 5 minus, yeah, you have to take the minus log of each P of x, and then you have to do. Yeah. Can you tell me the final answer, anyone?
Sir, log 5.
the 0.69?
Yes, sir, 0.69.
Okay, 0.69. Okay, great. So, okay. Okay, so we are done with the most major concepts of week 1. So we have some questions. Okay, would you like to solve it right now or after the week 2 concepts, once we finish the week 2? Okay, let's do quickly. Okay, let's finish week 1 right now. Okay, this is the question. Anyway, I have given the answer, but tell me, okay, how C is correct. Okay, now I have. Now, okay, this is the situation. Consider a data set from an e-commerce company such as, let's say, Flipkart, that has details of customer behavior. So which of the following problems can be best approached using clustering?
C, in identifying inherent grouping.
Okay, why? So C is correct.
Clustering is
Sir, clustering is unsupervised learning. It uses
Correct.
without predefined labels.
Correct.
Yes.
Correct. Okay, so everyone is okay with C?
Yes.
All right, great.
Yes, sir.
Okay, okay. What about
Sir,
this
I
question?
didn't get.
See what? Okay, those who answered C, can you explain? See, I can explain it, but I would like to hear from you guys.
Sir, first option is predicting, so it is regression.
Okay.
And second option is classifying customer the classification problem. And last is reducing the number dimensionality reduction, sir. So remaining is clustering.
That's
Can you share the PDF of this so that we could revise from there?
Yeah, PDF I will share once after this session. Okay, I will upload under within the under supplementary content, and there is one
Okay.
folder, right? Yeah.
Option D, what defines?
See, option D is just it's a dimensionality reduction, right? We are not doing dimensionality reduction. It is asking what which which is the correct for clustering, right? So clustering means you are
Clustering.
making groups, right? So this okay, what the data will do? I mean this is unsupervised learning, yes or no? Yes or no? So it will identify
Yes,
inherent groupings in customers. Yeah. So the first question is okay. So in a sport analytics company, the team is interested in predicting whether a basketball player will score above 20 points in a game using classification models. Okay. So okay, this is classification model, right? So above 20 points or below 20 points, right? They collected data on various factors, let's say x1, x2, x3 from the past game of different players, and the this is the situation, right? So the factors include the minutes played, shots attempted, and free throw percentage. Anyway, so the data and all is given to you. So x is 1, 5, 0.8. These are x1, x2, x3. This is output. First of all, this is supervised learning or unsupervised learning?
Supervised.
Supervised learning.
Okay. Why supervised learning?
So it is a
Yeah, it's labeled data, right?
Label data.
Okay, very good. So we have to compute the misclassification rate if they use the following setup. So what is the U of Z? You have to take 1 if Z is greater or equal to 3, 0 otherwise. And the Z is defined like this. Okay. So first of all, what is the misclassification rate in case of this classification problem? What is the formula? I would like to hear. How will you calculate? Basically, we have to calculate the loss. What
Through
is
the
that?
classification indicator formula.
We will calculate those which won't match with the Y's. Those.
Yeah, tell me the formula, because in
1
So
by
1 by n, summation of I is equal to 1 to n,
very good.
f of xi minus xi.
1 into
indicator
I
f of
times
xi not equal to
not
y.
equal to
yi, right? Not equal to
Yes.
yi. Okay, so you can just try, just no, concept should be clear. So you have xi's and yi. So as we discussed, in within this classification, you can see. So in this classification, we discussed that we have input and we have labeled output, right? Input, output, and here output is 2 classes, right? Now what we are wanted to see. So what is our goal basically? So our goal is this f of xi should be approximately close to yi, right? So we want to see the loss for the given f of for the given model. We would like to see 1 upon n summation I is equal to n. Basically, it's the misclassification rate. Okay. Okay. All right. Great. So just solve this and let me know what is the answer.
Okay, I have a question. That's supposed to be three variables, but here I can only see two. In X.
3 variables? No, 3, right? It's 1, 5, 0.8. Is it not visible to all of you? Now is it
No, sir,
visible?
it's visible.
Can you see it?
Okay.
It's 1, 5, 0.8. Actually, there is a issue of space. So it's a 0, 3, 0.9. I have written here. You can take it from here. 1, 2.7, and the next is 1, 8.6, and the next is 0, 7 is 0.5. So this question is from one of the previous year. I don't know from where it is exact term, but yeah. So this will give you some confidence. So I would encourage to all of you, please try to solve it.
Sir, 1 by 5.
Sir, 1 by 5, sir.
Okay, I don't. I have to solve it. Don't worry. Okay, should I solve it? Okay, so 1 by 5, I got some 2 votes for 1 by 5. We will see whether it's correct or not.
So 1 by 5.
1 by 5, okay. Yeah, so 1 by 5 answer is correct, 0.2. Okay. Okay, let me solve it. Okay, so because we have, okay, so what are those? X is there. So basically X is size are 1, 5, 0.8, okay, and then 0, 3, 0.9, and the next is 1, 2.7, and 1, 8.6, and the next is 0, 7.5. This is X size. What is the Z? This Z is basically, you can say this is Z is defined as 0.6 comma x1 plus 0.3 comma x2 plus 0.1 comma x3. So this is x1, x2, x3. So if you see 0.6 comma 0.6 times 1 plus 0.3 times 5 plus 0.1 times 0.8. So basically 0.6 plus 1.5 plus 0.08. So 2.18, right? Okay, so what next we have to do? If you see U or Z, if Z is greater or equal to 3, we have to take 1, otherwise 0, right? So what will be here? What will be the case here? It's 1 or 0?
0.
Because this is not greater
Less
or equal
than
to
3.
5, right? What about this part? Can you tell me the values, those who have calculated, so that we can keep
0 for this one. 1 for this one, yeah.
0.99.
0.99. So this will be, it will predict the 0, right?
0.
Okay, then next, it seems again less than 3. So 0.6 plus 0.6 plus 0.07. So 1.27, if I'm not wrong.
Yes.
1.27 is less than that. So
3.
it's 0. And then 1 8.6. So 0.6 plus 2.4 plus
3.06.
yeah 3.06. Then it
1.
will predict 1, right? Okay. And everyone is getting how I'm writing this, right? Based on this part. And then next is
2.15.
which is again less than is 0.
0.
So first of all, what is the original prediction? 1 0 0 1 0, right? So this is the original y, right? 1 0 0 1 0 1 0 0 1 0. So you can see what is the what is the average loss actually here? There is only one, right? This is the only one which
1 by
misclassification, right?
5.
Okay, so basically here loss will be 1 by 5, and here only one case, so 1 by 5 is 0.2 is the answer. That's all. Everyone got this?
Yes,
Is it
sir.
clear?
Yes, sir.
Okay, great. Okay, so let me move to the week 2 concepts. Okay, so I will quickly go through the concepts and then we'll try to solve some questions, or should we solve the questions directly? What do you suggest?
Sir, concepts.
First concepts.
Concepts.
Okay.
Questions.
Okay, I will go see.
No, sir.
I will write.
Concept.
Okay, so we'll not go into too much depth, right, as professor discussed in lecture, because we have time limit and this is just a revision. So we are hoping you have covered the concept, but yeah, we'll quickly cover the concept. Don't worry. So in week 2, we'll start with the continuity. Okay. So what is the continuity? So a function f of x, okay, I will say is continuous at x equal to a. When you will say this is continuous, if f of a is equal to
If limit exists.
extended
to a
yeah, means basically left hand limit and
right hand
limit.
limit.
Okay, don't worry about these things. We will try to solve some questions also. Okay, so and what about the next concept? I mean, after continuity.
Differentiability.
Okay, so what does what is the role of differentiability? How will you explain the differentiability?
Slope of the
Tangent to the curve. The rate of change.
Yeah, rate of change. Yeah. So basically, how will you calculate it? Basically, I will go to the how will you explain. So a function f of x is differentiable at x equal to a if, yeah, tell me. F dash a, basically I can write limit extended to basically left hand limit. Can I
Left
write
hand
f
limit
of
equals to right
x
hand limit.
minus f of a divided by
X
x minus
minus
a?
A.
This should be equal to x tending to a plus f of x minus f of a divided by x minus a. Okay, so see, I'm not going into too much that graph and all basically. So basically, it's see what this f dash a. What is the meaning of this f dash a? Basically, it's slope of the tangent. Yes or no?
Yes, sir.
So basically, if I would like to write, so I can say this is the slope of the tangent to the tangent to what?
Curve.
Curve. Which curve? X comma f of x at x equal to a. Okay, so basically what is this limiting process do? So this limiting process is the, you can say, basically it will, okay, let me draw one quick graph. Maybe suppose I have graph something like this. Okay, I have curve something like this. Okay, so what this differentiability does basically, so color, so sorry for the bad drawing, but you got it right. So this is the idea about slope of the tangent to this curve. Okay, yes or no?
Yes, sir.
Yes.
Is this clear? Okay, so well,
Yes, it is clear, sir.
okay, so the next is linear approximation. Okay, so if you see this formula, right, this one f dash a, right, is okay. Basically what else can I write? If suppose this is the approximately equal, okay, this suppose this f dash a is approximately equal f of x minus f of a divided by x minus a. Okay, so from here what else can I write? Can I write f dash a into x minus a is approximately equal to f of x minus f of a?
Yes, sir.
Okay, so if I want to approximate the curve, basically, so from where can I write basically what is the linear approximation does? So f of x is approximately equal to f of a plus f dash a into x minus a. So this formula came from there. So basically you can consider this as a linear approximation to this curve. Yes or no?
Yes.
Okay,
So
so
find the value of function near a.
yeah, at a, near a, you can see basically,
Near
or you can say, I can say, see, around a. So what is the idea about this linear approximations? Basically you can approximate the behavior of a function at a point with the help of its derivative. Okay, so basically you want to know how the function behaves. Basically I can say this is not equal to in an approximate sense around a. Okay, so this around a, so this is the way. So if you see the notation which sir has used, so it's L of a. This is the notation. If someone is writing like this, so you have to see it's f of a plus f dash of a into x minus a. Okay, all right. So for example, Okay, suppose I will take very simple example. Let's say f of x is 3x plus 8 for it. So okay, and around 0, at 0, what will be L0 f of x? Will be f of a. So basically it's f of 0 plus f dash 0 into x minus 0. But see what I'm trying to say here, but let's see. So what is this f of 0 is what?
Function value x equals to 0.
It's 8.
8.
What is f dash 0?
3 into x.
0. It is 0.
Yeah, so it is 3. So it is 3.
It 3.
3, right?
Yes. 3, yes.
3 times x. You got 3x plus 8. So which is the original one, right? So why we got the same thing? Because this is already, it was in linear form, right? If you want to approximate a linear function with the linear function, that you are getting the same, right? So what is the meaning of linear approximation? I mean, what is the concept of linear approximation? I mean, you have some curve, some different curve, let's say x square plus y square, and you want to one linear approximation. The way you can do this is the way. Okay. So okay, so basically, see, okay, there is one observation. So this is indeed the equation of a tangent line or not?
It is.
How?
Yes.
Yes. Sir, 3 is a slope of the line and 8 is a...
Okay, basically, what is the equation? Can I write y minus y1 equal to m times of x minus x1?
Yes.
Right.
Okay. From where can I, what is y equal to y1 plus m times x minus x1?
Yes.
Yes.
What is this? Can you relate this now?
Yes.
Okay, great.
Yes, yes.
Okay, so okay, this is for okay. What about higher order approximation?
For linear only it is applicable.
Yeah, this is linear only. So if you see for higher order approximation, okay. So yeah, Taylor series we are using actually. So higher order. So first of all, what is the linear approximation we have done? So linear approximation. Okay, what is the Taylor series? First of all, how if I want to write a Taylor series, how will you write the Taylor series?
Yes. So how higher order approximation also I did.
Yeah, my question is, what is the Taylor series?
First we write first order approximation, then like x square by 2 factorial, then
yes,
We can write it as sigma f dash of a, like that, power n into 1 by I factorial into x minus a power I factorial. I runs from 0 to like that.
Okay. Yeah, anybody else? Yeah, that's correct. That seems correct.
so we can write 1 plus x square by 2 factorial up to xn by n factorial.
No, x square f dash value
Sir,
also.
it is
So
f of a
basically,
plus
yeah, basically I can say f of x is f of a plus f dash a
Yes.
into x minus
divided
a
by 0
plus f double
x
a divided by 2 factorial
two
into
factorial.
x minus a whole square,
Yeah, yes.
and plus so
double
on, right? Plus similarly. So basically someone told in terms of sigma. So what is this f of x is equal to, let's say summation n equal to 0 to infinity f n a divided by n factorial into x minus a raised power n. Okay.
So do we need
So
to
this
learn
is
this?
yes, but you have to learn actually.
No, you have to practice. We'll practice, then we'll automatically learn something.
Correct. So
Start from
basically,
logic. We use some logic, then we'll automatically it will be called.
yeah. So what is this Taylor series allows us to basically approximate, complicated function with, polynomials, etc. So if you see in linear approximation, what we did actually. So we did L of x is equal to f of a plus f dash a into x minus a, right? Till this here. Should be approximately like this.
For single dimension,
single dimension. Yeah. Now, if you see higher, if you go to higher order approximation, so that there is called quadratic approximation. So in quadratic approximation, actually, so we'll take till here till the double derivative part. Okay. So what your L of x will be f of a plus f dash a into x minus a plus
f double dash
a divided by 2 factorial into x minus a whole square. This is quadratic approximation. Okay. So whatever the curve you have, see, suppose you have x square, right? If you will apply linear approximation, it will approximate linearly like this. Okay. If you will apply quadratic, it will approximate something like that. So you can try with Desmos actually.
Excuse me, sir.
Yes.
So sorry to interrupt, but that linear approximation formula, we have same formula for steepest ascent and descent also, right?
Steepest
ascent and descent.
Yeah, that for that I will come to that point. Don't worry.
I mean to say same formula we have, na?
Steepest, yeah.
No,
Like,
for the vector.
See, that is okay. Okay, so see, first of all, let's try to understand in the single, and then we will see in multivariate terms. It will be clear that steepest, I mean that gradient is steepest descent.
Yes.
Ascent,
Okay.
Sir, I have another doubt. Sir, when we apply linear approximation to a quadratic equation, like in the example you showed, we get a tangent to a curve, right?
Yes.
If we apply this higher order approximation, quadratic approximation, what will we get? Will we get a curve instead of a tangent line?
Yeah. See, that will approximate, right, properly. It depends how many like till what you are approximating, right? Whether you are approximating till this first derivative or second derivative or higher order. So
but
if you
in
see,
terms of graph, what does it?
If you see the graph of sin x, right? So sin x graph will look like something what? Some
goes up, goes down.
Goes up, goes down, right? Okay. If you'll apply the single linear approximation, right? So let's say something like this. So some graph will be like this sin x, right? So something like this. Yes or no? Something.
Yes, sir.
Okay.
Yes, sir.
Suppose you are applying linear approximation. So it will approximate something like this.
At a point.
Okay. Let me say something like that. Okay. So just try to understand. It will approximate something like this. Okay. Now
Yes,
suppose you are applying the quadratic equation. I mean, you are approximating till this quadratic approximation. It might approximate something like this.
Yes.
Okay.
Yeah, that's what I was asking.
Yeah, you're getting. So till suppose you are going till a higher order, it will approximate too much closely. Okay.
Okay.
Got the idea? Yeah. So
Yes,
this
sir,
is
yes.
not the correct graph, but yeah, I'm just giving you a rough idea. So in higher order approximation, how it will extend basically? So it's a f of a. I can write f dash a x minus a plus f 2 or let's say double dash a x minus a whole square divided by 2 factorial and plus f
triple dash.
Yeah, 3 factorial x minus a whole cube and so on. Okay, this is the way.
So practical purpose, 2 or 3 up to 2 or 3 order approximation is enough, I think. For
Yeah. See, for simplicity, we are dealing with linear approximation. That is very helpful.
So basically, for higher approximation, just apply the TLS formula.
TLS formula, yes. So if I will say this multivariate, linear approximation. Okay, so let's try to understand because there you might get some questions related to this. Okay, so see what is the meaning of multivariate linear approximation? Yeah, it means you are doing linear approximation of functions involving multiple variables, not a single variable. Here you see we are dealing with single variables, right? Okay, so what is the case? What is the formula for single variable? So L of x is f of a plus f dash a into x minus a. So this is for single variable. Now
Yes.
for multiple, suppose what I'm uh, going to write the linear approximation of a function f, let's say, of two variables. I mean, see, we have function of two variables. Initially, suppose we had a function of single variables. So let's say those two variables are x and y. Okay. So suppose I'm going to approximate in the neighborhood of a and b. Basically, neighborhood of point a comma b. How will you do? So this is L of x. So how will I write? So L of x comma y. This is f of a comma b. You can relate now. It was f of a comma b plus we have f dash of a, right? For it was for single variables. What else can I write? Del f of, so it's a partial derivative at a comma b, right, into x minus a, right? So you can treat one derivative at point a. Now it's a at a comma b and into x minus a. But we are dealing with multiple random variables. So the next thing will be del f divided by del y at a comma b into
x
y
minus b.
Not x minus, y minus b, right?
Y minus b.
Okay. Is it clear now?
Yes, sir.
Okay. So if this is the clear, then we have one question. Okay, but anyway, let me finish that directional derivative thing and then I will come to this point. Okay. So what is this direct? Okay. What this directional derivative does? Anyone? What is the idea behind this directional
The
derivative?
gradient of f into unit.
Okay, what is the idea?
How fast the graph will grow in a direction, like
basically, can I say
In
it's
only
the
one direction.
rate of
basically it's
change of
how rate of change in a single direction, maybe.
Okay, so if I'm writing directional derivative of, okay, before this let's tell me if I'm writing, let's say, f of x comma y, let's say, and I'm denoting del f of del x comma y. Okay, for example, just forget this. Write like this. So del f of del x, let's say, at x comma y. This x comma is point. So how will you interpret this?
Rate of change of x.
Yeah. Basically, can I say rate of change of f, okay, as we vary x, right? Yeah. And keeping y fixed. Okay, this is the meaning. What if I will write del f divided by del y x comma y? So this means rate of change of f as we vary y keeping x fixed. Yes or no? I mean, are you
Yes.
okay? Would you agree with me? Yes. Okay. Now, if this is the role of partial derivatives actually, so what is the if I will say directional derivative of f of x comma y. So this means we want to know the rate of change of function f if we allow both x and y to change simultaneously, okay, in some direction q.
So
Would
there
you
should
agree
be
with
a
me?
point also.
Sorry?
There should be a point, specific point also with direction.
Yeah, yes, I wrote right in some direction u.
Okay.
Okay. So basically, the way we can represent, so del u, I mean du. So this is in direction u, directional derivative of f of xi. So this is nothing but gradient of f into u. So see, this gradient is very, very important actually. So what is the gradient? Gradient is collection of partial derivatives, if you want to understand in simple terms. So what is can I write? So this is del f divided by del x and del f divided by del y, right, into u1 comma u2.
Yes.
Okay. So what else can I write here? Can I write u1 into del f divided by del x plus u2 into del f divided by del y?
Yes.
Okay. Is this clear?
Yes.
Yes, sir.
Okay. Now, okay, so there is one concept actually I forgot to tell you, that is contour plots. Okay. So what is the role of contour plots? What this contour does? Anyone?
To visualize all possible values the function can take in a domain.
Okay.
Sir, it basically say how a dependent variable change across two independent variables.
Okay. Yeah, correct. Yeah, your voice is breaking. So basically, see this.
To visualize the like three.
Your voice is breaking, but anyway, okay. So basically, let me basically why it's useful. Basically, what is the okay? Why it's useful? I will tell you. Then I will tell you what is the contours plot. So why it's helpful? Because it will help you to visualize 3D data on a 2D plot. Would you agree with me?
Yeah.
Right. Okay. So basically, in optimization, which we learn in week 8 onwards, so optimization. So contour plot shows how an algorithm moves toward this lowest point, basically towards the minimum error. So don't worry about optimization. So contour plots, basically it will help you to visualize 3D data on a 2D plot. Okay. So that's the one way of looking at. So okay, first if I would like to write, so this contour plots I can also call as a level curves. Yes or no?
Yes.
Okay, these are the level curves. These are obtained by slicing this surface with planes and parallel to, which is parallel to xy plane. Okay, anyway, so see, if let's say I have function and I'm going to visualize there's a function f x comma y. I'm going to visualize this x square and y square, and let's say this two variables is visualized like this. So x comma y comma f of x comma y. So I'm going to visualize in, let's say, R3. Okay, so and then we will see. So first of all, we will having, see, the meaning of level curve. So suppose I have after this, so I can write fx of y as 1, fxy as 2. Yes or no? Some different values of basically what we are interested. Okay, let me draw it. I had okay, so suppose this is x square plus y square. So this is 3D plot of x square plus y square. Okay. Now, if you see the contour plot, so f of x, so let's say is
Those concentric circles in the.
Yeah, so we can take f of x comma x square plus y square equal to 1. So can you see this gray line 2D?
Yes.
Okay, if I will extend to 3D, so now are you able to visualize now?
Yes, sir.
It's basically a cylinder.
Yeah, cylinder curve. Now, if you let me use something else, so let's say x square,
Okay,
plus
is there a way we can extend it to the opposite side also?
4. 1 second. So you can see now the red circle.
Yes, sir.
If you extend 3D, now it's already mixed up, but are you able to see, right? So these are the contour plots actually. If I will use something else, so let's say I'm going to use x square plus y square, sorry, equal to, let's say 9. Now you can see this green curve, right? Green circle. Are you able to see, right? Let's say this gray one, then maroon, and then green. Okay, so actually, if see now I'm making it 2D. So now it will help you to understand the surface in 2D. Yes or no? Are you getting my
Yes, sir.
idea? Okay. Okay, so these are the idea behind contour plots. Okay. Okay, all right. So then let's move on to some questions of week 2. Okay. So this is the one of the question. For what value of b is the following function continuous at every x? Okay, so I would like to, please try everyone.
Yes.
This is one of the question because you will get some idea how to solve these kind of questions.
Option C.
Option C.
-2.
Option C. Okay, I need to solve it. I just so I got 2 votes for option number C. I will wait for 2 more minutes and then.
So -2.
-2. Okay.
Yes,
It's
sir,
the
-2.
-2.
Okay, so -2. Let's see the answer. So okay, answer C is the correct. Let's see how to solve this. Okay, so what is the formula to check continuity? So
Left
as
and
we
right.
discussed,
Limit should be equal.
so this f of a, right? So continuity, to check the continuity, f of a should equal to limit x tends to a minus x tends to a, basically left hand limit f of x, this should equal to
X plus.
right now. So here what is the point basically?
0.
0, right? So what is the limit x tend to 0 minus f of x? Okay, what should I write? Basically to prove, okay, what we have to use, so we have to use this part, right? 0 plus f of x and f of 0, right? Because I'm saying the question says it's continuous, but we have to find out the value of b by using this information. Yes or no? This equation. Okay. So what is the left hand limit? So limit x tends to 0 minus f of x. So this is, we have to use which one? So it's a
First one.
0 minus b, right? Divide by b plus 1, which is minus b divided by b plus 1. Yes or no?
Yes, sir.
So then for the right hand limit, it will be 0 square plus b, which is b, correct?
Yes.
Right. So what next? What is f of 0? Okay, first of all, then we need to equate these two, right? So minus b divided by b plus 1 equal to b. So what else can I write? So I can write minus b equal to b times b plus 1, which is implies minus b equal to b square plus b. So from here it will be b square uh,
2b.
plus
So
2b
we can
equal to,
eliminate B.
yeah, basically it will be b plus 2 equal to 0. So here b is either 0 or b
Or
is
-2.
minus 2. So okay, which one is correct then? B is
Both.
minus 2. Okay. Okay, so minus 2 is the correct answer. Okay, clear?
Yes.
Okay, so this
Sir,
was one of the question in one of the
So
PY.
if we
Sir,
have
minus
the
2 is in the
both
option.
option
That's why.
-2 and 0, then both will be correct, right?
Yes, sir.
Yeah, both will be correct. Yeah, so minus 2 was in the option. That's why. Okay. Yes. You have any doubt? You have raised hand, Abdullah. Oh, it's by mistake.
No, sir. It was by mistake.
Oh, okay, okay, no problem. Okay, what about this question? Next question. So f of x is a function is given to you, ax square plus bx plus 1, x is less than 0 and cx plus d, and it's given is differentiable at x equal to 0. So if a, b, c, d are constants, so which option is true?
Option B.
B option. B.
Option
B.
B option.
Okay, I got some 2 votes for option B. Anybody else?
Yes, sir. Option B, sir.
Option B. Okay. Let's see the answer. Okay, option B is the correct. So how will you approach? What should be your first approach?
Sir, first we will according to continuity, equate
Okay.
and after differentiate and then put the value.
Okay, so to check the continuity, what we have to do? We have to check the limit x tends to 0 minus f of x, and this should be equal to right hand limit, and this should be equal to f of 0, right? For the continuity. Yes or no? Why we are checking with the continuity? Tell me, what is the reason?
So because it is given that it is differentiable, so it must be continuous
Continuous.
also.
Okay, great. All right. So this limit x to 0 minus, basically what should I write? Yeah, ax square plus bx plus 1 for the left hand limit.
Yes.
Yes.
Okay, what should be answer here?
1.
Sir, 1.
1. Right. Now, what about right hand limit? Basically, so this right hand limit will be d.
Yes.
Yes.
Okay. What about f of 0?
D.
So D.
D. Right. Okay. Now, okay. So now we for the continuity. So from the continuity, can I say d is equal to 1, right?
Yes.
Okay. So now we have two options, D, B, and C, and D also, right? I mean, A is we can eliminate. So now we have to check the equality of left and right derivatives at x equal to 0, because it says it's differentiable at x equal to 0. Yes or no?
Yes, sir.
So what should be first approach? I mean, how should we?
So differentiate LHL.
So basically limit. Okay, what if you see we have discussed here how we have to proceed? Limit x tending to 0 minus and f of x minus f
of x
0.
minus f of a by x minus 0. Yes.
Okay, basically what we have to differentiate then? Tell me. Basically
In
d
place
of
of a, we'll compare with 0.
basically we have to do the derivative of ax square plus bx plus 1 at x equal to 0. Yes or no? This is the meaning.
Yes, sir.
So if you differentiate, it's a 2ax plus b, right?
Yes.
2ax plus b at x equal to 0. What you will get? I will get b.
B.
Yes.
Right. Now for the right derivative, so limit x to 0 positive f of x minus f of 0 divided by x minus 0. Basically we have to find the derivative of cx plus d at x equal to 0. Now from here I will get c, right? Now from the equality, from this concept, right, from this concept I have to equate this left hand to right derivative, right? So what I will get? I will get b equal to c. So b equal to c and d is equal to. Okay, is this clear to all of you?
Yes, sir.
Yes, sir.
Okay, now you can
Yes,
see
sir. It's clear.
the concept we have discussed, how simple it is, right?
So we are quitting the differentiation of the left and right side. Eh?
Yes, yes, yes. That's the definition of differentiability, right?
Yes, yes.
Okay.
So then we directly first instead of doing the quitting the continuity, uh, can't we directly use the differentiability?
See, if you include, so you will get one condition b equal to c, right? If you use the concept of continuity, because see, if it is differentiable, that means it is continuous also, right? So by using the continuity concept, we got one condition which is d is equal to 1.
Okay. Yes, yes.
Okay.
One parameter. Yes.
One parameter. Okay, so well, so the next question is, okay, please everyone try this. So this kind of question is important actually. Okay, so just try this. This is, you have to do linear approximation, but here it is, it's first of all, you have to use univariate or multivariate.
Multivariate. Two dimensional.
Two dimension, right? What will be the formula? L of x comma y.
Is equal to f of a comma b.
Okay, here you can see L of x comma f of a comma b.
Yes.
F of a comma b plus del f
Derivative, yes. Del x minus a.
at, see, del of del x at what? At a comma b.
A comma b.
Right? Into x minus a plus
Del
del f
f
divided by
by del y
at
at
a
a
b
comma b times
into
y minus b.
Very good. Now please try to solve this. So I have given, let's say, some 2 to 3 minutes. Just solve it and let me know.
So C option.
Okay, let's see. I mean, option C is correct, but everyone please try and let me know. Then we will try to solve together.
Yes, sir. Option C.
Option C. Okay, some 2 votes I got for option number C. Okay, so everyone is able to follow me, right? Or
Yes.
yeah? Okay, great.
Option C is correct, I think.
Option C. Okay, let me solve. Okay, so option C is correct here. Answer is C. But okay, let's try to understand the problem. Okay, so this is the way we have to find the value of L pi by 2 plus 0.1. So this is A, basically x comma y. Okay, no, not A. So this is not A. So this is A, correct, at point around the point A comma B. Okay, now so what is the f of x? F of x comma y, sine of x comma y. So first, okay, what are the things we need? We need del f del x. Okay, so what is the del f del x? Okay, so basically del of del x, so sine of x comma y. So this is nothing but cos xy and then y into cos xy.
Y cos x
Y.
Okay, now what about del f del y?
X cos x.
X
X
cos
times cos
xy.
xy.
Okay, very good. So x into cos xy. Now we have to evaluate at point pi by 2 comma 0. Yes or no? Right? That's what we have to do. So first of all, we have first, what are the things we need? F of a comma b. So what is the f of x comma y is sine into xy. So all the things we have. Now we have to evaluate at point pi by 2 comma 0. So f of pi by 2 comma 0 is nothing but sine pi by 2 into 0, which is sine 0. Sine 0 is 0.
0.
Let's make it equation number star. Now next thing we need del f del x at a comma b. Are you getting? So del f del x at a comma b. So what is the a comma b? It's pi by 2 comma 0. So what is the del f del x? So it's a y into cos xy. So it's a, it will be 0 into
0 into cos
0.
0.
So anyway, it will be 0 only, correct? Because 0 into something.
Yes.
Then del f divided by del y at pi by 2 comma 0, which is x into
Pi
cos.
by 2 times
Yeah. Oh, sorry.
Cos
0. Cos 0.
So it will be pi by 2 into cos 0. So cos 0 is 1.
90 degree.
1.
One.
So it's
One.
pi by 2. Alright. So we have all values now, right? What we have to do? We have to substitute in equation star. Now substitute in equation star. So L of x comma y will be, what is the f of x comma y? Basically f of pi by 2 comma 0, it's a 0. So it will be 0 plus, okay, let me write. So f of a comma b plus del f del x at a comma b into x minus a plus del f del y at a comma b into y minus b. So here we have x comma y and we had f of pi by 2 comma 0 plus del f del x at pi by 2 comma 0 into x minus a. So what is the x minus pi by 2 plus del f del y at pi by 2 comma 0 into y minus b. What is the y? I mean y is y, b is the 0, right? So this is value, this value we got as a 0 and this value is again 0 into x minus pi by 2 will give you the 0, right?
Yes.
Plus what is the del f del is the pi by 2 into y. Basically we got
Pi y by 2.
Pi y by 2. But this is L of x comma y is pi by 2 into y. But we have to calculate L of pi by 2 plus 0.1 basically. So L of pi by 2 plus 0.1 into, I mean comma 0.1. So basically it will be pi by 2. Don't consider it as x. So it will be, so basically it will be into 0.1. So pi by 2 is 1.57. This is 0.1. So 0.157. Okay. So option C is the correct. Okay.
So in last line, we have pi, like pi's value is 3.14 and we are adding 0.1, and after adding we are dividing.
No. So this is considered, we have to replace this x, whatever the L of x comma y we got.
Yes.
Suppose here some term related to x, suppose like this. Okay.
Yes.
Then what you will do? So this pi by 2 plus 0.1 you have to substitute in the place of x, and this 0.1 you have to substitute in the place of y. Understood? So since see in this original case we don't have x, right? So that's why we used only pi by 2 into this y part. Okay.
Okay.
Clear?
Yes, sir.
Yes, sir.
Yeah, great. So you can see how. Okay, now what about? Okay, let's solve this next question. So consider the function f of x comma y. So function is x square plus 3y square. In which direction does the maximum directional derivative occur at the point 1 comma 2?
Maximum direction will be the maximum direction derivative will be in the direction of gradient itself.
Correct. Then what is the formula for that?
So gradient of f by norm of gradient of x to the whole square. Like this something.
No. What you have to see? See, you have to find the direction of maximum directional derivative, right? And what first you have to calculate the gradient vector, and then compute the partial derivative,
Yes,
and you have
sir.
to finally compute the
Yes, so we have
gradient.
to find a gradient vector at point 1 and 2.
See what is the maximum directional derivative occurs in? Okay, let me write this maximum. Now maybe it will be clear. Maximum directional derivative, basically this occurs in the direction of the gradient vector, okay, which is normalized. Now is it clear? Yes, no? What you have to calculate?
Yes, sir.
Sir, is the option I'm getting is B.
Okay, option
Sir,
B. A. Okay, one vote for option number A, one vote for option number B.
So C.
C. Different
C.
answers. Okay, C.
C. Sir, C.
C. Okay. Okay, let me saw. So who said option number B?
So myself.
Okay, great. Girish, right? So option number B is correct actually. Let's see how. Okay, so first of all, what is my function? So function is f of x comma y is x square plus 3y square, right? To get the directional derivative, what else we need? We need what else we need?
Firstly, we need partial derivatives.
We need this, right?
Yes.
Gradient of f into u, and
unit.
this is the unit vector, yes or no? So first of all, what is the gradient of f? So it's a collection of these partial derivatives. So this gradient of f is we
2x.
need basically del f, del x, and del f, del y, right? So what is this?
2x.
2x comma
6y.
6y. All right. Now, and what about gradient at point 1 comma 2? So this del f at 1 comma 2. What is this? This is
2 comma
12. Right. Now we know this maximum directional derivative, I told you it occurs in the direction of the gradient vector, which is normalized basically as a unit vector. Okay, so what is the first of all, to make it a unit vector, what is the magnitude of this?
2 root 37.
Yes, sir.
So basically it will be 2 square plus 12 square, which is
2 root 37.
2 root 37. Okay, very good. Now what is the unit vector now?
Yes, sir. One by
Gradient divided by this magnitude.
Right, very good. So this is 2 comma 12, which is this gradient at point 1 comma 2. So it will be 1 upon square root of 37 and then 6 divided by square root of 37. Is this clear now?
Yes.
Okay, yeah, correct. So actually more or less we are done with from week 2. So for week 3, should we cover the concept quickly and then solve the question?
answer is different, same or different? This one.
No, answer is same. This B is the correct option.
B is the correct option. Oh.
Yeah. Okay. Okay. So all right. So what about this part? Tell me for week 3.
Yes, sir. Week 3 concept.
Concepts and then questions,
Yes,
or should we solve questions and along with that we can discuss?
sir, first concept.
Okay. Okay. All right. So let's go with for the week 3. Okay. So what are the main content in week 3? So it's 4 fundamental subspaces. Okay, and then orthogonal vectors and subspaces. So okay, if suppose some topics is missed out for some reason, but in case, so we will cover during the questions. Okay, then we'll solve the questions. So projections, and then what is that? Least squares.
Least square solution.
Okay. And projections onto subspaces. And then some example. Okay, first of all, what are the 4 fundamental subspaces? See, I'm not going to discuss the now definition of vector space and all, because I hope you guys
Row
are
space, column space, null space, and left null space.
okay. So suppose I have a matrix. Okay, suppose A is a m cross n matrix, order of m cross n matrix, and A is something like this. So A11, A12, and it will be A1n, right? Then A21, A22, A2n, and then it will be AM1, AM2 till AMn. Correct? This is the order. So first of all, the very first thing is called column space. Okay, so the column space of A, usually we denote as a C of A. Okay, which is, can I say this is a subspace of, tell me what should be, RM or RN?
RN.
RN.
RN?
Yes.
RM.
Tell me subspace RM or RN?
RN.
NN.
RN. It should be N, sir. Number of columns.
RN.
No, RM.
Okay.
It should be M, right?
Number of rows.
Yeah, just think.
It should be M.
RM.
And why? M or N? Yeah.
Each vector in the column space has m components, right? So it's
The M. Actually, columns are M and rows are
Yes,
N.
sir.
Yes.
Columns are vectors, so there are n vectors or n columns.
Should be
so
M.
M for
Okay.
member.
Each column has m entries.
It should be M. Okay. Now, I will come to the what is the column space and those things. And the next is next fundamental space is called row space. Okay, so row space is also same as column space of A transpose actually. Okay, I can write. Would you agree with me or not? So this is,
Yes,
I can
sir,
write
of
a row
course.
space of A. So this is subspace of
Rn.
Rn, yeah,
Rn.
correct. Now the third is the null space, and which is we denote n of A, and which is just subspace of Rn. Okay.
Sir, I am still confused for Rn and Rm for row space and column space. Because A is going to A1, A2 up to An. It means
Okay.
n columns we have.
We have n columns, yeah, correct. But which is, see, okay, what will be the rank first of all?
Rank are the independent
Independent
columns, pivot elements.
Pivot elements.
Okay, see, okay, first of all, see, what is the dimension of the column space here?
And at most n should be.
At most n, okay.
Yes, sir.
So if you see like A1, A2, A3 up to An we are going, then column should be n.
Okay. Okay, anybody would like to explain this part? Today.
So in this case, sir, column space is the CA is the column space. So number of number column space means this number of rows.
Yeah, go ahead. Yeah.
Yes, the column space means how many columns are there, na?
Yes.
So
see, column space is linear combination of columns of X.
Yes, sir. So they are the m linear combinations of rows.
But if you see rows, we are going A1, A2 up to M. And if you see in columns, we are going up to N.
If you see in rows, right, like each row has each vector has n elements. So each vector with n element can span only those n element thing, right? So it will be Rn for a row. And if you see it column wise, there will be m components in each vector. So that can span only Rm. It's based on number of components it has.
Like we are seeing alternatively.
Yeah, of course, if you imagine a row has A11, A12 up till A1n. That means there are n components in that. So
in column space of A, what we are doing, so suppose all the columns, okay, suppose see, we have to solve, let's say, Ax equal to B, okay, suppose this problem we have to solve, then it will be A11, A12, A1n, and AM1, AM2, AMN, correct? And what will be, this is M cross N, this is N cross 1, and this will be, let's say, B1, B2, Bn. Okay, till M, what is this order? This will be M cross 1. Okay, so far so good. Let's say x1, x2, so on, xn. Now, what will the, how will you solve this? Can I write A11, A21, or AM1 into x1?
Yes.
Yes.
Plus, are you getting this way?
Yes.
A12, A22, AM2. Okay, let me write, maybe if this
times
is
A2.
Okay, if this is confusing for you, how will you write this one? You will write A11 x1 plus A12 x2 plus so on, A1n xn equal to B1
P1.
A21 x1 plus A22 x2 plus so on plus A2n xn
is equal to B2.
Something similarly, AM1 x1 plus AM2 x2 plus so on, AMN xn equal to
Bn.
Bn or Bm?
M.
Right. So if you see this is, can I write the same thing as A11, A21 as AM1 x1 or not?
Yes.
A12, A22, AM2 x2
Yes.
plus so on plus
AM1
AN A2n am and xn equal to, let's say here b, vector b. Okay.
Yes.
So what is this left hand side? This is just a linear combination of columns of matrix A. Yes or no?
Yes, sir.
So this is column space of A. All right. So if you see set of all linear combinations of A, right? So first, if you see the rank of A, basically, what is this rank of A? Rank of A is nothing but, yeah, tell me.
M at most M.
Independent rows.
So see that it depends on the dimension also. So what is the dimension of rank of A? So rank of A can be
Minimum
maximum
of m comma n.
N maximum.
It should be minimum of m comma n.
See, first of all, if you see each column of A is a vector in Rm or not. That's just go with very simple terms. If you have any confusion, each column of vector, how many? What is the dimension of each column?
Even
in Rm, right? So if you have, let's say 1, 2, 3, this is in. Can I say in R3?
Yes.
Okay, so if you have m vectors, so you will say m subspace of Rm or not?
Yes.
Okay. So someone explained, right, regarding m elements in each column. So that's the idea. Okay.
Yes.
So so column space of A is nothing but linear combinations of all the columns of A. So what is the row space of A? So suppose, okay, for example, I have matrix A, okay, and matrix A is, let's say, 1, 4, 2 and 2, 8, 4, and then -1, let's say -4 and -2. Just suppose this is. And what is the column space of A? Column space of A basically, it's you have to see the all the linear combinations of A, right?
Yes, 1, 2, -1.
And
4, 8,
columns of
-2.
A basically.
Yes. And last 2, 4, -2.
Okay. But before that, we need to apply something called, row reduced echelon form.
Yes.
We have to see that.
RREF.
Yeah. And okay, but for that, okay, if you want to see the row space of A, so row space is what? If row space is what? The linear combinations of rows there, right?
Yes.
Right. Now, if you see linear combinations of rows, okay, if I will say, let's say A transpose, so A transpose will be 1, 4, 2,
4, 2,
2, 8, 4, -1, -4, -2, which is say, okay,
transpose.
which is same as, can I say,
column space of A.
Column space of A transpose.
Yes.
Okay. So if you have calculated the row column space of A, then to find out the row space of A, it's good to go with the column space of A transpose. Okay. How will you go for null space of A?
Number of variables.
Zero elements and number of free variables.
Yes, sir.
So basically, we have to solve the set of all vectors in Rn such that Ax equal to
0.
Right? So if we say, so null space of a set of all vectors in Rn such that Ax equal to 0. What about left null space? What is the idea about left null?
Ax equal to B.
So A transpose, I think it is A transpose. If we find A transpose x equal to 0, then
okay, basically, first of all, so basically, if you see, we have to find the set of all vectors y in Rm such that A transpose y equal to 0. Okay.
Yes, yes.
So if A transpose y equal to 0, so can I say y transpose A equal to 0 transpose? Yes or no?
Yes.
Yes.
So why it's called left null space? Because this y, this you can say this act on A from the left side. Okay. See, I'm not going into too much detail because it's just a revision session. I'm quickly just covering the concepts, and we'll try
So
to solve some.
is it not possible to write A transpose Y? Not possible.
No, it's not like that, not possible. So we are going from here to here. Okay, so we are taking transpose on both sides, and
Oh,
we are solving.
yes,
So
yes, yes, sir. Yes.
okay, so these all things. Let me let's try to solve this for A. Okay, for A. Okay, so A is something 142. Okay, 284, and then -1, -4.
-4, -2.
Okay, so what is the correct way to approach to find out column space of A? First, we have to
Row
convert into
reduce.
row reduced echelon form and try to see how many pivots are there, right? So what we can do R2 such that,
-2 time R1.
yeah, R2 minus 2 times of R1 and R3 plus R1.
Yes.
Okay, so it will be 1, 4, 2, and it will be 0, 0, 0, and then 0, 0. Is it correct? Yeah. What is the pivot? Pivot is this, right? Only first column?
Yes. Only
Right?
rank is 1.
Rank is
And
1 and pivot is
null
first
space
column. So
is
what is
0.
the column space of, what will the column space of A?
First column.
1, 2, -1.
Yeah, it's a span of
1, 2, -1.
very good. So it's a 1, 2, -1. Okay, what is the rank of this matrix if you see?
1.
Rank of A is
Yes, sir.
1.
1.
Right? Why is the 1? Because there is only one independent
Variable.
And what about dimension of this column space?
1.
1, sir.
Okay. What is the basis? Basis?
1, 2, -1.
1, 2,
1, 2,
-1.
-1. Because basis is what? Pivot columns only, correct?
Yes.
I have a question. Why are we saying that CA is span of 1 to 1 instead of saying CA is span of 1 for 2? Like
No,
the
so
pivot is 1, but
which column has pivot column? Pivot thing. First column, right?
yes.
And you can see other two columns are dependent to first one.
Okay.
Understood?
Okay.
Are you getting this point or not?
Yes, yes.
Okay. Yeah. So okay, what about row space of A? So we say, so row space of A. Okay, row space of A is the same as
Column space of A.
column space of A transpose, right? So first of all, to calculate what is the A transpose? So A transpose is
142.
142,
284.
284, and then -1,
-1,
-4,
-2,
-2. So we have to convert in row reduced echelon form. So what we can do, R2 is such that
-4
R2
times 1.
minus 4R1,
2
very
time
good,
R.
and
R3
R3,
-2 time R1.
yeah, R3 minus 2 times of R1, very good.
R1.
So what we will get? We will get 1, 2,
2
-1,
-1.
again 0, 0, 0,
0, 0,
0, 0, 0. Okay, so this is the pivot.
Yes, yeah. Now I also confused. Yes.
And now the basis is clear. 1, 2, -1.
Yes.
Now tell me, what about this? What will be the this row space, which is same as column space of
A transpose.
Okay, what else can I say?
Span of 142.
Span of 1 to 1.
142.
2 -1.
142.
See, we are dealing with row space of A. Can I directly say it's first row, which is 142?
Yes.
Right? Very good. Now, what about null space of A? So to calculate the
2.
null of a space of A, what we need? Ax equal to
0.
0, right? So first of all, what is the A row? Okay, what is the row? So we know this Ax is what? Let's write.
So here we can use rank nullity theorem directly.
Yeah, we will use. Don't worry. So 142, 284, and then -1, -4, -2, -1, -4, -2. So we have x1, x2, x3, and let's say this is 0, 0, 0. And as per the procedure, what we have to do? We have to convert into this row reduced echelon form. So, and we know, and you can see we have converted already by using this row operations. We got 142. It's got 0, 0, 0, 0, 0, 0. Now it's x1, x2, x3, which is 0, 0, 0. Now tell me, what are the free variables?
x2 and x3.
X2 and x3. And what is the equation? X1 plus
4x2
plus
2x3
2x3
is
equal
equal to
to
0.
0. Right? So this is the pivot variable x1, right? And
Yes.
x2 and x3 are free variables. So what is the case? Okay, so
x2 is equal to 0.
x2 and x3, they are
Free variables.
right? So I can substitute. Let's say I'm putting x2 as a 1 and x3 as a 0. Then what we will get? We will get
x1 plus
But x1 is
4.
equal to -4.
x1 equal to -4. If x2 is 0 and x3 is 1, then x1 equal to
-2.
plus -2, right?
Yes, sir.
Right. So okay, now
I have a question.
Yes.
So, if we take one pivot variable and we find out a relation, a linear direct relation with the other variables, like suppose x1 is equal to 3x3, then x3 will not be a free variable, right? It will be a it would be bounded to x1, right?
No. So free variables means basically, see here first column is the independent, right? It's the you have pivot columns, correct?
Yes.
So x1 is the free, and other two are the sorry, x1 is not free, and other two are free variable, right? If you see,
Yes.
correct. So we can substitute x2 as 1 and x3 as 0, or since we have two variables. See, if you have one variable, you can take 1 or 0, something like that, correct? And since we have two, so I will take x2 as 1, x3 as 0, and x2 as 0, and x3 as 1. Okay. And then what will be the case? What will be the null space of A? It will be span of, yeah, tell me, -4,
1, 0.
1, 0, and -2.
0, 1.
Yeah. So it depends, right? How many free variables are there and how many, first of all, you have to identify the pivot column, and then you have to decide the free variables and all. Okay. I mean, basically, see, pivot columns are independent columns, and free variables means those are the dependent columns. Okay.
Sir, we are assuming the value of x2 and x3 according to
that is free variable. So the standard way is to substitute 1 and 0 and 0 and 1.
Okay, sir.
Okay. Okay. So the next thing is, if you are done with this part, so I would like to solve this question. Okay. Everybody, please, can you solve this?
Multiple choice, right?
So
Yes,
B is
multiple.
correct.
Which one?
B.
Okay, B is the correct.
Sir, A also.
Okay.
C will also be correct, I guess. C
Okay, I'm just clicking as a correct. We will see whether it's correct or not.
So D is incorrect.
Okay, D is incorrect.
Incorrect.
Okay, so only 2 or 3 people are solving. What about others? I mean, you are not trying, or what else?
So B is correct.
B is correct. Okay, great.
Sir, A, B, C.
Okay, A, B, and C. Okay, should I solve or should I wait for a few minutes? If you are trying. B, right?
Sir, A is also correct.
Okay, A is also correct. Okay, so majority is saying A, B, and C. Okay, so A, B, and C are the correct options. Okay, let's see. So I will go with options. Okay, option wise. First of all, if you see this matrix A, right? If you focus, so second row is the 3 times of row 1.
Yes, sir.
Right.
Yes,
So
sir.
that means what? Rank of A is not
1.
So rank of A is 1. Okay.
1.
Now, for the null space, what we have to do? We have to solve A x equal to 0.
0.
Right. So if you see, so what is the case here? If you see 2, 5, 6, 15. Okay. So this will be, let's say, x1, x2 equal to 0, comma 0. So this is 2x1. Okay, first of all, if you convert into row reduced echelon form, right? So let's
2,
convert
5,
it.
0.
2, 5, 6, 15, right? So if you see, I can write R2 such that R2 minus
3
3
times.
R1, and what I will get 2, 5, 0, comma
0,
0, correct?
0.
So if I will convert here 2, 5, 0, 0, so x1, x2 is equal to 0, comma 0. First of all, this is the pivot, right? So
Yes.
x2 is the free variable, right?
Yes, sir.
Basically, what we are getting 2x1 plus 5x2 equal
5x2 is
to.
equal to 0.
So from here, I can say x1 equal to minus 5 by 2 x2. Someone asked doubt something regarding this. Okay. So what is this now? Tell me.
We can substitute x2 equal to 2.
Right. I can substitute x2 equal to 2 or not, because this is free variable, right?
Yes.
So if x2 is equal to 2, then x1 is minus 5. So null space of A is span of minus 5 comma minus 5 and understood?
So how you put the value 2, because we can put any value, right?
Usually it takes 0 and 1,
X2
right,
is
sir?
independent. We can put any value.
Yeah, x2 is a free variable, right? x2 I can take anything. See, as per the option, I'm going with that, right? Usually you
Yes.
can take 1. So it will be null space of A will be span of minus 5 by 2 comma 1, something like this. Okay.
Yes, 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 yes. I get it.
Understood?
Yes, sir.
Yeah. What about column space of A? So to solve the column space, basically, what we need to solve? Ax equal to B, right? So again, it will be 2, comma 0, 5, 0, x1, x2 equal to b1, b2. So, okay, which column is dependent one?
First.
No, I mean,
Second.
see, second column is dependent, right? 5, comma 15 and 5 and 15. So this is 2.5 times of the first column. Okay. So column space of A directly will be what? It's a span of first column. which is span of 1, 3, right? 2, 6 or 1, 3, which is same as. Understood?
It's the same.
Yeah, 2, 6 or 1, 3.
Okay.
I mean, basically, you have to take 2 outside, right?
Okay, I got it.
So span set is what? Spanning means what?
Covering the whole vector space.
Like, how will you write? What is the meaning of span?
Like after multiplying or adding, we can add more and more and more.
We can get any
So all the
vectors.
linear combination of set.
Right? All the linear combination of those things, correct?
Yes.
So see, if you see 2, 6, what else you can write? 2, 1, 3, right?
Yes. I got it.
Understood, right? Now,
Yes.
left null space of A transpose. So left null space of A transpose. So how will you write left null space? Basically, what we have to solve? We have to solve A transpose y equal to 0. Right? So what is the A transpose? So A transpose is basically.
It's basically we just reduce it. Reduce
2,
the
5,
A transpose.
6, 15.
6, 15, right? And this is let's say y1, y2 equal to 0,
0, 0.
Now what else can I apply there? Can I say R2?
So 2 times R2 minus 5 times
R2 minus
R1.
2.5 times of R1? Yes or no? I will get 2, 6, 0, 0, y1, y2 equal to 0, 0. What else we got? 2 times of y1 plus 6 times of y2 equal to 0. And we got 2y1 minus 6y2. So basically, y1 equal to minus 3y2. See, which one is a free variable?
Second row.
Second, okay, right? So y2 is a free variable. So y2 I can take, see as per the option, I can take 1. Right? So y2 is 1. Then y1 is minus 3. So third option is correct. Is it clear? Are you getting right?
Yes,
sir.
It's the span of minus 3, What about row space of A? So to compute the row space of A, which is same as column space of A transpose. Right? So column space of A transpose. So first of all, what is the A transpose? A transpose will be
2, 5,
2, 5, 6,
6, 15.
Again, same operation. R2 is R2 minus 2.5 times of R1. I will get 2, 5, 0, 0.
Sir, that is A. We wrote it as A transpose.
Yeah, that is A transpose, right? See, calculating row space of A same as column space of A transpose, correct?
The matrix A transpose is wrong.
8, 2, 5. Oh, sorry. It should be 2, 6 and 5, 15. Yeah, correct. Thanks. 2, 6. Yeah, correct. So it will be 2, 6 and it will be 0, 0, correct? Yes or no? Now this will be, again, you can take anything. Let's say y1, y2, 0, 0. Let's take x1 itself to make it clear. Okay, so now see, second row is the dependent one, right? So what should be row space of A? It should be span of
2, 5.
2, 5, right? First row, correct? But in the option it is given 2 minus 5, which is wrong. Okay, is it clear?
Why is not? Is it to show the answer in the cell? In this case, column this one 2, 6 this one 2, 6 equal to so this should be 1, 3 sir. 2, 6
No, actually so in case of row space, if you see directly, you can directly see from it. So second row is the sorry, this is A transpose, right? Column space of A transpose. Okay, if you see in the original row, so second row is the dependent on the first row, right?
Yes, sir.
So what will be the row space of A is the span of the first row, which is 2, 5. You can see directly from here also. Okay.
Non-zero row in the REF form.
Non-zero row, yeah. in row reduced echelon form.
Yes.
Okay, so till this point everyone is okay?
Yeah, okay.
Okay, so the next thing is I would like to discuss that's called orthogonal. Okay, orthogonal vectors. Okay.
So I have a question.
Hmm.
In a how many pivot in a could be in a matrix? We take
Depends on the order
we
of
take
the
the
matrix.
independent variable as a pivot.
It depends on the matrix order of the matrix.
It might be more than one.
Yeah, might be more than one pivot.
Okay, sir.
Okay, suppose you have matrix something like this, A is equal to some, let's say 3 cross 3, right? And what is the row reduced echelon form? You solve this matrix and you got one pivot here and 0 0 and 0, some value here and 0 and 0 0. So you got
Yeah,
all
that
are.
actually, this
So
is the
here
actual
rank,
question in my
yeah,
mindset.
so rank was here rank will be 3 because all are independent.
Yes, sir.
Okay.
I'm
Okay, so what
wondering
is
in
the
the same way.
orthogonal vector? Suppose you have vector x like this and some vector no y like this, and suppose there
Perpendicular.
perpendicular actually, and there is right angle. So
Yes.
okay, can I say this is sorry, this would be straight. Forgive me, my bad drawing. So can I say this is x plus y?
Yes, sir. Yes, sir.
If you see the vector addition,
Yes.
right? So
Yes.
this is what this is right angled triangle or not?
Yes, sir.
Okay, if this is the right angled triangle, can I write from the trigonometric idea this norm x square plus norm y square equal to
No.
norm of x plus y square? Would you agree with me?
Yes.
Yes, sir.
What is this formula says?
Pythagoras theorem.
Pythagoras theorem, right? In terms of matrix, what is the norm square? Can I write? Can I write x transpose x? Yes or no?
Yes, sir.
Yes.
So why this is true? Because suppose x is x1 and x2. So if you write x transpose x, so this will be x1 and x2, and here x1, x2, it will give you x1 square plus x2 square. Clear?
Yes.
Right? So this is x transpose x. This is y transpose y.
Sir, we are doing dot product here.
Yeah, dot product. See, norm is defined like this. Okay. A dot product also. So what else can you say for this? Can I say x plus y transpose into x plus y?
Yes.
Right? Now, if you see here, I can write x transpose x plus y transpose y. This is same as if I will expand this, I will get x transpose x plus y
Y transpose
transpose
Y.
y plus x transpose y plus y transpose x. Yes or no?
Yes, sir.
Yes, sir.
Correct?
Yes, sir.
I just multiplied like this. So this two will get cancel out. What I get here 0 equal to 2 times of x transpose y to make the order. Now from here, what else can I say? X transpose y equal to 0. So this is the definition of orthogonality. To check whether two vectors are orthogonal or not, you have to check their dot product, basically x transpose y is equal to 0 or not. Or else you can check this part, whether the norm of x square is equal plus norm of y square is equal to norm of x square plus x plus y square or not. So for example, suppose I am taking example x as a 1 2 3, and y is 2 minus 1 0, and x plus y let's say 3 1 3. Okay, now what is the norm of x square? Tell
14.
me. Basically it's 1 square plus 2 square plus 3 square, that is
3
40.
square. Yes.
What about this y square, norm of y square?
5.
5.
5.
And norm of x plus y square?
Root 19.
You can see addition of these two is same as this one.
Yes.
Yes, sir.
Or else what is the x transpose y if you multiply it? So 1 into 2 2 minus
0.
2 plus 0, which is
0.
so here x and y are orthogonal vectors or not?
Yes, sir.
Okay, so you got the idea, right? So whenever you will say any in subspace, right? Subspace, any subspace is orthogonal to another subspace. So what does that mean? That means every vector. Okay, so let me write that statement. So let's say subspace S is, if I will say this subspace is orthogonal to uh, subspace, another subspace T. This means, every vector in S is orthogonal to every vector in T. Okay, this is the meaning of subspace, orthogonality of subspace. So there is two things. Row space is orthogonal to. I will not go into derivation. I'm just giving you the idea. So row space is
Null space.
Null space.
Is orthogonal to
Null space.
null space. Very good.
And column space is orthogonal to left null space.
Correct. So column space is orthogonal to left null space. Okay. So okay, all right. So this is the idea, and can you solve this question? Okay, these two. I mean, this is the question. You have to identify which options are correct.
A is obviously true, we can understand that.
Okay, A is true.
Same for same for C also.
Same for C. Okay.
B is wrong.
Sorry?
B is incorrect.
B is also true.
B is true or B is wrong?
D for dog. D for dog is true.
D for dog is true. Okay. Why B is wrong?
Sir,
because column space is
left null space.
Left null space.
There should be left null space.
Correct. So correct options are actually A and D. I think
Length will be √3.
Yes, sir.
Yeah, length is √3, right?
Yes, sir.
Whenever you have to calculate length is the square root of basically
square root.
Basically norm A, basically, which is square root of.
So once please explain first option.
See, first
How
option
this
says this vector is orthogonal to this vector and this vector, right? So what is this? This is, let's say, x, and this is, let's say, y. This is z. So how will you check the orthogonality? To check whether two vectors are orthogonal, we have to check x transpose y is 0, and where you have to check x transpose z is 0. Correct? So if you see x transpose y, so what is the x transpose? 0, 0, 1, and y is 1, 0,
1, 0, 0.
So it's 0 plus 0 into 1 plus 0 into 0 plus 1 into 0, which is 0.
0.
And if you see x transpose z, so it's a 0, 0, 1, and z is 1, 1, 0.
1, 1, 0.
Again, it's a 0 plus 0 plus
Sir,
0.
Sir.
Yes.
So actually option B is wrong because of this is matrix column space is perpendicular to the transpose of A, na?
Yes, so this column space is perpendicular to left null space. So left null space is A transpose, basically.
Yes.
Okay. If here it is written as row space, then it's correct, because row space is perpendicular to null space. Okay, understood?
Yes.
And see, length is should be square root of 3. So whenever you have to calculate the length, so length of any vector is let's say vector x. So it's let's say here it is A, so it is this is, and it is square root of, it's 1 square plus 1 square plus minus 1 square. So it should be square root of 3 actually. Okay. And D says these are orthogonal vectors, so we have to check. So let's say this is x, this is y. So what is the x transpose y? So x transpose is 1, 2, 3, and y is 1, 1 minus 1. So it will be 1 into 1, right, plus 2 into 1 plus 3 into minus 1. So it will be 2 plus 1, which is 3 minus 3, which is 0. So it's correct. Okay, understood? Orthogonality is correct. Clear to all of you?
Yes, sir.
Yes, sir.
Okay. So the next concept is projection. Okay, so I will quickly go.
So I think orthonormal
Okay, what is orthonormal? Orthonormal is very
length
basic.
should be 1.
Length should be 1, right? And for that, what you will do?
Under root of
Divided by norm.
we'll check
Yeah,
norm
you have
of
to.
that.
Yeah, you have to divide by.
It's norm.
Divide by its norm.
Yeah, yeah. Basically, if you have vector A, let's say, if you have vector A, right, which is to convert in orthonormal, what you will do? Basically,
A by
A by
norm
norm
of
of A.
that thing.
Okay.
Yes.
Is it clear, right? I am not going to do this.
Yes, sir.
Okay. So next concept is called projections. Okay, so I will quickly go through this projection. Okay, why projection and all, you can explore more on it. So this is just for revision. So okay, what is the projection? Let me draw some graph, and I will derive the formula actually. Okay, from where it
So
came.
the formula is dot product of u dot v by u dot v into v.
Okay, so suppose this is, yeah, correct. This is A, and this is, suppose, vector B. And what is this? This is, let's say, projection P of B onto A, right? So okay, what is this? If you see this part, okay, this is the P, right? And if you see this point, this P is what? This is some constant into A, some value into A.
Yes, sir.
Right? Suppose this is whole A, this might be some value of A. Yes, or no?
Yes. Yes,
Actually,
sir.
basically you can say half A, 1/3 A, something like that.
1/3 A around.
Something
Yes.
like this, right? And what is this? This dotted line, can I say this is the error difference between B minus P? So far so good?
Yes, sir.
Now if you see this, okay, can I say this is orthogonal or not?
Yes, sir.
Yes, sir. It is perpendicular.
It's a
to
perpendicular.
B.
If this
B
is perpendicular,
to
so
B.
by using the perpendicular concept, can I say A transpose into B minus P is equal to 0? Would you agree with me?
Yes, sir.
Correct. What is this A transpose? What is this P? This is X times A.
Yes.
So from here, can I write
A transpose B
A transpose B minus
A transpose
X into A transpose A equal to 0?
Yes.
From here, what can I get? Can I get X equal to A transpose B divided by A transpose A? Yes or no? So let's say this is small p. And what is this p? P is nothing but X into A or A into X, right?
Yes.
So what is this p? P will be, what is the value of X here? You can tell me.
A transpose B by
Let's
A transpose A.
write like this, A into X. So what is this? A transpose B divided by A transpose A
times A
into A.
Yes, sir.
Yes, sir.
Or else, okay, let's go with that XA only.
XA.
What is X? What is X? So A transpose B divided by A transpose A. Okay, and what is this A here, right? A.
Yes, sir.
So to convert means to make it in proper, can I write A into A transpose divided by A transpose A into B?
Yes, sir.
Okay, if you are getting confusion, let's write like this AX only. Okay, if you will write like this AX, now I think it should be clear, right? No, this is the P. Okay, so this is the P. What is projection? So projection P, if you, I can write P into B. And what is this? P into B. See, this projection P is what? P into B. This capital P. So this capital P, I'm just extracting. So this is A into A transpose divided by A transpose into A.
B.
Okay. So this is projection matrix actually. Okay, is the idea clear from where this formula came?
Yes, sir.
Okay, so there is two property in case of this projection. What is the first property? Projection matrix. P transpose is, yeah, it's symmetric and
whatever
P
the
square equal to P.
this
whatever
is
the
two
power is, it will be yes.
P. And see, because we are projecting again something like that. So why projection? Why project is important? Because see, sometimes this ax equal to b, this solution, right? We may like this may have no solution. Yes or no?
Yes, sir.
Yes.
Okay, this may have no solution. So what we will solve? We will solve ax hat equal to p. Okay, so what is this p? This is projection of b onto column space. Okay, see, there is some derivation also related to this. If you want, we can discuss in upcoming session. But as of now, is the idea clear regarding projection?
Yes.
Okay.
Yes, sir.
So okay, let's try to solve this question. Where it went? Okay, all right. Can you solve this?
One by two times 1 minus 1 0.
Option B.
Option B. Okay.
Fourth.
I mean option D.
So, sir, suppose vector 1 to 1 is the original vector, and we need to find its projection on this vector. So we need
See, you have to be clear. So see here, here what is this? This B is projected on A, right?
Yes.
This is projection of B onto A, right? So you can treat this as a B. You can treat this as a A. See, you can do is vice versa also. What will be the change? Change will be formula here. So it will be B transpose B. Okay.
Sir, option B and C.
Option B and C.
B and
Someone's
C.
okay. I got 2 votes for B and C. Very good. Okay, should we see the solution?
Yes, sir.
Yes, sir.
Okay, great. So, okay, what is the case? So, we discussed, right? If you see, this is A, right, and this is B. We are projecting B onto A. And what was the projection matrix? Projection matrix is, if you see from here, it's the A transpose divided by A transpose A, right? See, you can take vice also. I mean, you can take this A and this is B. The formula will get changed, but the idea should be clear. Okay. So, okay. So first of all, and this is projection matrix. Okay. Okay. So what is the case here? What we have to calculate? A transpose A. So what is the A transpose A?
2.
So this is sorry, not like this. So it will be
1 minus 1 0.
1 minus 1 0 and 1 minus 1 0. So it will be 1 plus 1, basically 2, right? Okay. So this value is 2, and what is this? A transpose, basically
1 minus 1 0.
1 minus 1 0 and 1 1.
So बीच में
1 minus 1 0.
1 minus 1. Sorry. So so what is the order here? So B and C is there. So this is 3 cross 1, 1 cross 3. So usually I will get 3 cross 3, right?
3
After
cross
the
3.
so it will be you can say 1 and then minus 1 and then 0 minus 1
1
1 and
0.
0 and then
0, 0,
0, 0. Everyone is getting how I'm writing like this, right? So what is the
Yes,
projection matrix? So projection matrix is what is A transpose A is 2 and this matrix. So basically projection matrix will be 1 by 2 into this matrix. Is the idea clear how we got the answer?
Yes, sir.
Okay, so 1 minus 1 0 minus 1 1 0 0 0 0. What is projected vector? So projected vector, how will you calculate projected vector?
Multiply projection matrix with B.
Right. So this is projection matrix and this is okay, projected vector basically. So this projection matrix into B. So this is 1 by 2, 1 minus 1 0 minus 1 1 0 0 0 0. What is the B? B we took as a 1 to 1. Yes or no?
Yes.
So this is 3 cross 3, this is 3 cross 1. Usually I should get 3 cross 1. So if you see 1 minus 2 and 0, so this will be minus 1 and minus 1 and 2, this is 1 and this is 0. So option C is correct. So D is not correct actually. So minus 1 and 1 0 is. Okay, understood?
Yes.
Sir, excuse me, sir. So this one in the question sir. This one is the first one you have taken as a B. You have taken as a B.
Okay, don't memorize as a B. You can take it as A. So what you have to understand? So this is B onto A, right? This is projection of B onto A.
Oh,
so
so
this
this
will be
one-
B. You can do in vice versa. Projection of A onto B. The formula will get changed. Then this will be B transpose divided by B transpose.
But if you use formula as given the question, then we have to take this one as to be to project on the second one, na?
Yeah, B on A. Yes.
Yes. Oh, that's nice.
Okay. What sir used in lecture? What is the notation?
No, it is in the
The
A transpose
same
into
notation. A transpose by A transpose A.
But in the case B is projected on A. That was the.
Okay. Okay. So
Sir, I have a doubt.
Mm-hmm.
I always get confused with the MLT because parallelly MLT is also going. There the scalar is B transpose A divided by the norm like A transpose A. So like we get the scalar and we multiply with the direction vector like W, I mean the A. So in that case, I got the answer as the last option. That is the always the confusion in it's same concept, but only that
No,
thing
no,
is
no. So you are talking this. This is incorrect. This one is correct.
that's what. So like in MLT, they say that the scalar is B transpose A divided by A transpose A.
It's not B transpose A. Okay, did you get this idea? I think the concept is the same. Maybe you are making some calculation mistake. Did you get this idea? This projection matrix?
I get this idea. I get it. But
yeah, that's what is the issue. This B, if you are calculating so projected part, so this we have to calculate B, and this is the projection matrix, right?
that is true, sir. Like in the MLT, what they do is whenever we project a vector onto A, then we get this. I mean that projection is some scalar multiple of A, right? Like as you said.
Yes.
That scalar value in MLT, what they teach is, for example, take this image. That scalar is that axis is nothing but B transpose A divided by A transpose A. They tell it like that.
No, maybe there is something. I mean, I need to cross check. I'm not sure about that part. So this is the actually correct one as of now. Okay. So this x is coming out to A transpose B divided by A transpose A. I mean, you can see the whole derivation. Okay. Okay, so I need to check this MLT part, or else you can just okay, what you can do, just take the screenshot of that part and you can tag to me on Discourse. I will check it out. Okay, what is the confusion between? Okay, I will try to clear. Okay. Okay, so the next is the linear, least squarest approximation. Okay, so what is the least squarest approximation does? I mean, why it's necessary? Anybody?
To
What
fit
is the
the line to to fit the line in the data, like a
yeah,
scattered data.
yeah. What is the key idea actually? Suppose you have input independent, you output. Let's say you have height data and you have weight data, and you have data something like this: some point here, some point here, third point here, fourth point here, and 5 point here. And what you want to do? The linear approximation does you have to do you are going to fit a linear line, okay? And you will try to find out what is the basically someone in the beginning he asked error sum of the square, so that is come from here. So what is the error? So this is the error, the difference between actual point and the fitted line. The difference between actual and fitted, difference between actual and fitted, difference between actual and fitted. So what we try to do, we are trying to find the values such that this error is minimum. Okay, there's something called best fit. So in linear algebra, what happens? See, most of the time, sometimes actually this ax equal to b has no solution. Okay, this has no solution. What is the usual reason it will have no solution?
B does not fit
Because
to
both
the
are
following
parallel.
case of A.
Can I say too many equations? Right? Too many equations means, can I say A has more number of rows than columns, or else more equations than unknowns? Yes or no?
Yes.
More equations than unknown.
So shouldn't it be less equations and more unknowns?
More equations. I think, see, suppose you have three. Okay, yeah, I think, yeah. More, see, if you have three equations and two unknowns, it's possible, right?
Then it might have solutions. No, sir. So for no solutions, there should be more unknowns.
I think less equation and more unknowns give infinite solutions, right?
Uh,
For example, let's consider
got it.
like x and y, and x is equal to 1. So y can be anything in that case. It's kind of infinite solutions.
Yes. Sir.
See, if you have, let's say, first of all, lines should be something parallel, right? Right. In that case, you don't have to solution, right? You have no solutions, correct? Yes or no?
Yes, sir.
Yes,
Okay.
sir.
Another way is that actually, is this correct, right? More equations if you want to write.
There are more unknowns than the equation. Like if you have two unknowns and only one equations.
No, in that case,
Yes, sir, it's correct because if we have more equations than more,
see, in that case,
subject
you have
with the
infinite solution, right? I think.
multiple.
See what I mean by more equations and than unknowns. Basically, suppose you have something, let's say x plus y equal to 2, you got x minus y equal to 1, or let's say 2x plus 3y equal to 10. So see, I don't think can we solve this, right? It's inconsistent, right? Yes or no? Are you getting my point?
Yes, sir.
So in that case, it will have no solution. So that's why, that's what I mean. I mean more equations than unknowns. Okay. So basically, also see what happens in linear. Okay, is this clear? Why this more equations than unknown?
Yes, sir.
Yes, sir.
Okay. So in case of this linear approximation, actually we okay, what is this least square? I will quickly jump to that least square approximation. So in least square method, okay, what we have to solve? We have to solve basically A transpose A x hat equal to A transpose B. Okay, is this clear?
Yes, sir.
Okay, so basically, see see, you can't always get the error b minus ax down to 0, right? Are you getting what I'm trying to say here? See, let me come to this point. What about this part? This p x equal to, can I write p into b? This projection matrix into b, right?
Yes, sir.
Right, if you see now in terms of matrix and all, so this will be, can I write p equal to ax hat?
Yes, sir. Yes, sir.
Okay, and then from here, actually if you will solve this, so basically this basically what I'm trying to say, this capital A transpose into b minus ax hat equal to 0. Okay, if you solve this, so then you will get this formula, this formula, A transpose ax hat equal to A transpose B. So finally, if you solve this, A x hat equal to A transpose A inverse A transpose B. Okay, are you getting? So see why this is true. Now we are dealing with plane, right? I mean, in terms of matrix we are dealing. Okay, earlier it was vector. Are you getting? Everyone is getting this part. How this came? This came. This part. Yes. No.
Yes.
Yes, sir.
Right, so this came from this projection concept itself. Okay, if you solve this, you will get A transpose B equal to x hat A transpose A. I mean, basically it should be x trans, this should be, because we have to we have to maintain the order, so it will be A transpose A x hat equal to A transpose B. So this is what we have to do, we are doing in linear least square approximation method. Okay, so there is one question, we'll try to solve that. I think it's already 11:30, but
Yes, sir. In the mock test. Yes.
okay, so this is the question, right? So we have to solve, we have to find the best fit line. Okay, so basically, if you will plot this x y, so what is this? You will get 0 1, right? Where it is 0 1? This is 0 1 somewhat.
Yes,
Correct?
sir.
And 2 2, let's say 2 2 is here. 3 4, let's say 3 is here, 4 is here, right? 5 3. Suppose 5 and 3 is here, something like that, right? This is the graph of original data. Okay, so what we have to do, so this is x, this is y. So what we have to do, how will we solve this? We have to solve A transpose A x hat A transpose B. Right? Now, what is the A and what is the B here? Tell me. So
X
A
and
is
Y.
always
The value y and
A is 0, 2.
See, A is 0,
0, 2, 3, 5.
5 and 1 1 1 1.
1,
Yes.
1.
Okay, because we have to deal with intercept part, right? And what is the B? B is the
1,
output.
2, 4, 3.
1, 2, 4, 3.
4.
Very good. And x hat is unknown. We have to estimate. We have to calculate. Now, can you calculate this A transpose A? Or let me solve it right now. Okay, basically it will save our time. Anyway, so what is so anyway option A is correct. Okay, so A transpose A. Okay, so what is A transpose A? So basically it will be 0 2 3 5 1 1 1, and it will be 0 2 3 5 1 1 1 1. What will be the answer? A transpose A?
0, 2 plus 9 plus 25, 37. Yes. 37 and 5.
So basically this is 2 cross 4, 4 cross 2.
37 and 5. Sir.
Okay. So 37 and
5.
5. You are going row wise?
4, sorry, 4. 1,
Okay,
2,
4.
3.
And what about this?
Below.
Yeah, what is second row? So
10 and
2 plus 3 plus 5, right? 10?
8, 8, I think. No.
10 and 4.
10 and
10.
Okay. So this is A transpose A. Okay. So this is A transpose A X hat. So what is A transpose B? So basically A transpose is this again 0, 2, 3, 5, 1, 1, 1. What is B? B is 1, 2, 3, 4. So basically 1, 2, 4, 3 actually, not 3, 4. It's 1, 2, 4 and 3. So this is 2 cross 4. This is 4 cross 1. So I will get 2 cross 1. So what is the answer for this?
Sir, A transpose A matrix is wrong. I mean, second element.
31.
Sir, A transpose A matrix is wrong. Second element should be 10.
And sir, first element also it should be
Oh,
38.
okay. So I didn't calculate. Someone was saying I just simply. So this is 38. This is 10. Yeah, correct. Yeah, thanks for this. And what is A transpose B? So basically it will be 10 and this is 1, 2, 3, 4.
So it should be 31,
Sir,
10.
31 and 10. Sir.
31 and
31 and 10.
31 and 10. Yeah, all right, great. So what is the answer? How we have to calculate A transpose AX, right? A transpose AX hat equal to A transpose B, or instead of B you can write Y also. So basically you can write this notation as a X transpose X, some constant hat, let's say A hat, or X transpose Y if you want to write in terms of X or something like that, right? So basically you got the idea, right, how to write the matrix and all. So this will be 38, 10, 10, 4. So this is X hat, right? So
X1, X2.
X1 and X2 and
31 10.
not X1, X2. It's
theta dash and theta down.
No.
let's keep it X hat. Okay, so this is A transpose B is 31 and 10. Okay, so just solve this basically, and you will get the.
So we have to divide X hat into two components, no? Two
See, that
components.
is one component is intercept and one component is slope.
Yes.
Actually, okay. So if you see this A Y we are writing, right? So what is this? If you see Y equal to mx plus c, right? So what we are writing, this one is the intercept part, okay? So this x hat, let's say you are denoting as a, let's say, okay, x hat will be what? 38, 10, 10, 4 inverse, and 31 and 10, right? So suppose two values you got, okay? So as per the question you got, let's say I got 1.34 and
0.46.
0.46. Okay, suppose I got 1.34 and 0.46. This is my x hat, means this value is intercept and this value is slope. So what will be my best fit lines? Y hat will be 1.34 plus 0.4 times 0.46 times x. Understood? Okay.
Yes.
This is the way you to proceed for this best fit line in case of linear regression fit. Okay. And how we are getting this formula, you have seen this idea. Okay. Okay. All right. Is it clear to all of you?
Yes, sir.
Okay.
So
Sir,
please scroll little down
Hmm.
here. Wait.
Any doubt?
So it's a multiply, right?
Yeah, you can multiply from where and solve the equations, or else you can calculate the inverse and you will get this answer. Both are the same thing. Basically, what you can you can do 38, 10, 10, 4, and let's say you can do x1 and x2, and this is 31 and 10. So here you will get two equations, right? 38 times x1 plus 10 x2 equal to 31, and
Yes.
10 x1 plus 4 x2 equal to 10. Solve this, you will get this answer. Or else, by matrix multiplication idea, what else can I say? Can I say x transpose is what? X hat is A transpose A inverse A transpose B. Can I say this one or not? Understood?
Yes, sir.
This is the A transpose A inverse. That's what I did. Is it clear?
Yes, sir.
Okay. So the last question is to fit the, see now we fit the linear regression, right? What about this second order polynomial? So I will tell you the way how to approach in this kind of situation. Okay, any one of you, would you like to go ahead? If you have done this kind of questions, can you explain how to proceed? Yes, no, anything? Nobody?
Generally, I check the options to find the minimum errors, but I'm not sure how to proceed in the right approach.
Okay, well, so this is quadratic, right? So we have to find the minimum of yi minus this something. Okay, first of all. So, okay, anyone is you? There anyone who know how to do this or?
So we have to basically use an equation that y equal to ax square plus bx plus c, and
Okay.
then we have to form those matrices like we did before.
Okay, so what is the what is the idea? We have to fit this polynomial, right? So what is the y? Y is the theta naught, that's theta 1 x, okay, and
yes,
this is
that
theta
will square.
x square. This is something we have to fit, right? And data is given to us, x y is given to us, right? But for each data point, right? So how many data points is there in R3, right?
Yes, sir.
Okay, so the way I will tell you, so for each data point, if you see, just convert into the matrix form actually. So what else can I write? First of all, we have three data points. So what else can I write? Can I write y1 equal to theta naught plus theta 1 x1 plus theta 2 x2 square?
Yes, sir.
Yes, sir.
Yes, sir.
Y2
Yes, sir.
equal to
Now
theta
remember.
naught
Now remember.
plus theta 2 theta 1 x2 plus theta 2 x2 square. This will be x1 square actually, and then y3 is equal to theta naught plus theta 1 x3 plus theta 2 x3 square. So far so good.
Yes, sir.
Okay, now can I write like this in matrix form as 1 x1 x1 square 1 x2 x2 square 1 x3 x3 square, and then theta naught theta 1 theta 2 is equal to y1 y2 y3. Would you agree with me?
Yes.
Yes, sir.
Yes,
Yes,
sir.
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 And what are the x points?
Values. Yes. Put the values.
It's 1 0 minus 1, and y is minus 1 and 1, right? So if you substitute the values, what is you got? 1 1 1, 1 0 minus 1 and
0
square of
minus
these,
1.
right? 1 0 1
Yes.
Yes, sir.
theta naught theta 1 theta 2, and then minus 1
Minus
1
one.
and,
0, 0, 0,
so
0.
the better way is convert in augmented matrix and start row reduced echelon form, and that will give you a basic solution. Okay, so if you solve this, let's try to solve this. So what else we can do? Okay, you have idea about augmented matrix?
Yes.
Yes. Yes,
Okay,
sir.
just to
1, 1, 1. Yes, sir.
now let's make it, this is minus 1 and 1, right? Yes or no? This is, we have to
Yes.
substitute this matrix, right? Now, from here, if I will do, let's say R1 as R1 minus R2 and R3 such that R3 minus R2, let's do like this. So what else we got? We get uh,
R2 is R2 minus R.
if we do,
I think we can't do both simultaneously.
see, no, we can do, that's no problem. See, R1 is what? R1 minus R2, right? So if you substitute R1 minus
0
R2,
minus 1 minus.
so we got 0, 0 and 1, 1, 1, correct? And then R3 is R3 minus R2. Let's keep it 1, 0, 0. R3 is R3 minus R2. So 0 and minus 1 and 1, correct? Now what is R1 minus R2? So this will be minus 1 and this is minus 2 and 1 and this is 0. Now what we can do, the smart approach is we can replace these two, right? I mean R1 such that R2 and R2 as R1. Yes or no? Can I do?
Yes.
So it's 1, 0, 0, 0, 1, 1, 0 minus 1, 1. So it will be 1 minus 2 and 0. Now what next can I do? R3 such that R3
Plus R2.
Plus
plus
R2.
R2, right? So it's 1, 0, 0, 0, 1, 1, 0, 0, 2, right? It will be 1 minus 2 and minus 2,
Yes.
right? I think now we can solve it, yes or no? So what else we got from where? We got
2x3 is equal to minus 2.
Theta naught equal to 1.
see, first of all 2 theta 2 equal to minus 2,
Yes.
right? So this is theta 2 equal to minus 1.
Yes.
If theta, and from the second we got theta 1 plus theta 2 equal to minus 2. So from here theta 1 minus 1 equal to minus 2. So from here theta 1 is 3. And obviously from first one theta naught is 1, correct?
So theta 1 should be minus 1, I
Oh,
think.
sorry.
Yes, sir.
Yeah, sorry, not 3, minus 1. Understood? So what is the fitted equation? Theta naught plus theta 1 x plus theta 2 x square.
X
Right?
square.
So y will be 1 minus x minus x square. Is this clear?
Yes.
So is this clear or not? So to check whether this is correct or not, so what you can do, you can substitute all the points, right? X is 1, 0, minus 1. It should satisfy y, which is minus 1, 1, 1. So y is minus 1 and 1. So can you substitute x 1? So you will get 1 minus 1 minus 1. You will get minus 1. Just substitute 0. If you substitute 0, you will get 1. If you substitute minus 1, you will get again 1. So this is the best. Okay? Clear?
Yes.
Okay, so that's all for week 1 to week 3. I hope covered and you got some idea about the content. Okay. So anything else? Anybody? Or can you wind up? It's already about 12. So
Yes.
okay. All right.
Hello, sir.
Yeah. Go ahead.
Sir, can you solve the practice question of week 3? I have a doubt in row space.
Okay. Have you gone through the solution PDF?
No, sir. Sir,
Can you go on? Okay, just go with the solution PDF once. Okay. If still you are doubt, you can tag to me on Discord. That's not a problem. Yeah.
Hello, sir. Where can I download this PDF?
You can find it under supplementary content. Okay.
Supplementary content.
Yeah. I will upload after this session.
Okay, thank you, sir.
Yes.
Is the PDF is accessible by the morning, sir?
Yeah. Within after this session, so 12, 10 to 15 minutes, it will be accessible.
Okay, sir. Literally, sir, you are giving more intuition than the actual faculty in the videos.
Sorry, I didn't get what you're trying to say.
I mean, you're giving the more intuition in the subject than the faculties who was in the videos.
Okay. Yeah. So we are just trying to do some. Yeah.
Are trying to
Yeah.
complicate.
Where can I find that in the supplementary section? On the which
So
content?
under supplementary section, you can find out.
I see lecture transcripts, lecture PPT slides.
Not. It's the live session slides and notes. Can you click there? Okay, let me
Live
share
sessions. Yes, I do.
Let me share my screen. So can you see this live session slides and notes? So
Just
there
give me
is
a second.
something instructor sessions and TA sessions. So if you click here, after this session, I will upload it, so you can find it here.
Okay, got it. Thank you so much.
So I will upload these two PDF. I don't know whether you are able to understand my writing after this session. If is it okay,
That's
I
okay.
can upload it.
Yes, please. Yeah.
No, sir. Sure, sir.
Okay, all right.
Thank you very much, sir.
Thank you,
Have a good
sir.
night.
Thank you. All the
So
best. All the best for
and
your prison exam.
so your energy is another level. Without taking any break, you are just going on. Thank you so much, sir.
Thanks. Yeah. Thank you.
Thank you, sir.
Thank
Thank
you.
you, sir. Thank you.
Thank you, sir.
Thank you. Bye. Good night.